Isaac Newton calculated the date of the apocalypse. He believed the Temple of Solomon contained a hidden code for the size of the universe. He spent 30 years, in secret, trying to turn metal into gold. And when scholars finally opened his private manuscripts after his death, they discovered something that rewrote everything we thought we knew about the man. 1/3 of everything Newton ever wrote was not physics. It was alchemy, secret theology, prophecy, the father of modern science, the man who gave us gravity, calculus, and the laws of motion, spent more time searching for the philosopher's stone than he ever spent writing the Principia. The question that has haunted historians for 3 centuries is not what he discovered. It's why the most rational mind in human history lived a double life in the dark. Tonight, we go inside that darkness. Welcome to the Stoic Slumber. I'm glad you're here, wherever here is for you right now. If this is your first time, this is a space built for minds that don't stop moving, even when the body needs to rest. If you've been here before, thank you for coming back. Before we begin, if this episode gives you something worth keeping, a better night's sleep, a question you didn't have before, or simply the feeling of company in the quiet, leave a like, subscribe, and tell me in the comments where you're listening from. A city, a time, a single word. I read every one. To understand Newton's double life, we have to go back to where it started. Not to Cambridge, not to the apple orchard, not to the Principia, but to a small stone house in Woolsthorpe, December of 1642, where a man had just died 3 months before his son was born into the world. Chapter 1. The Abandoned Child and 47 Confessions. Isaac Newton was born on Christmas Day, 1642. According to the old Julian calendar, then in use in England. He was born early. Early enough, people said, that the infant could fit inside a quart pot. His lungs not yet strong enough. His skin wrinkled like a crumpled sheet of paper. 2 neighboring women were sent to fetch medicine while the baby was laid on a small pillow. And by the accounts that survived, no one was certain that when they returned, he would still be there. But he was there. He lived. His father had not lived to see it. Isaac Newton Sr., the farmer who could not read, who had taken his name from his own father and passed it on to his son, died in October of that year, 3 months before the boy arrived. We don't know what killed him. We don't know much about him at all. And that, in some strange way, says a great deal about everything that would follow, because the absence of a father can leave wounds as deep as his presence, sometimes deeper. Woolsthorpe Manor, if calling a 2-story stone house with a thatched roof a manor, is accurate, sat in Lincolnshire, in the middle of England. In winter, the flat land there met winds off the North Sea with nothing substantial in the way, and temperatures dropped low enough for water to freeze indoors by morning. Newton grew up inside this. Silent barley fields, stone walls thick with moisture, and the woman who was his mother, Hannah Ascott Newton, from whom everything he had came, and from whom everything that would weigh on him most heavily also came. When Newton was 3 years old, Hannah remarried. The new husband was Barnabas Smith, rector of a neighbouring parish, 30 years Hannah's senior, a widower with property. This was a practical marriage in a world where widowed women had few choices, and Hannah chose security. But Barnabas Smith did not want the Newton child, and so the 3-year-old Isaac Newton was sent away, not far, just across the village road, to live with his grandmother, Mrs. Ascott, an old woman, already tired, and by every account that survives, not particularly warm. Newton's mother lived less than a mile away for 4 years, and in those 4 years, the indirect evidence suggests, mother and son barely saw each other. Some children learn to fill absence with noise. They become wild, aggressive, desperate for attention from anyone willing to look at them. Isaac Newton did not do that. He filled absence with silence and with language. Records suggest that from a very young age, he began building small mechanical models from wood, miniature windmills, small carts with wheels that actually turned. Not to play, but to understand why they worked. But more important than those models was the notebook. Newton kept records his entire life. Not a diary in the ordinary sense, not pages describing feelings or the day's events, but observations about the nature of things around him, questions without answers, notes on light and shadow and matter and motion. And sometimes, only sometimes, in those moments when the line between natural philosophy and outright confession dissolved completely, he recorded other things. In 1662, Newton was studying at Trinity College, Cambridge. He was 20 years old. And in a small notebook with a leather cover, now held at the Fitzwilliam Museum in Cambridge, which is why scholars call it the Fitzwilliam Notebook, he wrote down a list. The title of that list, in Latin, means Sins Committed Against God and Man. There are 47 items. This is not a conventional religious document, not a prayer, not a ritual act of contrition. This is a human being sitting down, taking up a pen, and attempting, with the detail and systematic precision of a scientist, to take inventory of every wrong thing he had done in his short life. Some entries are small sins that any teenager might recognize in themselves. Used Neville's penknife without permission, allowed a candle to burn on the Lord's Day, did not keep a promise. But some entries, ones that historians have had to read twice to be certain they understood correctly, are something else entirely. Entry 9, wishing death and hoping it to some. And the entry that would become the center of every psychological analysis of Newton ever written. Number 13 on the list, threatening my father and Mother Smith to burn them and the house over them. Let us stop here. Threatening my father and Mother Smith to burn them and the house over them. This is a child, not a teenager, not a young adult. This is a small boy, perhaps 5 or 6 years old, standing before the man who had taken his mother and kept him from her, and saying, I will burn you alive. The fact that this memory was powerful enough that Newton, at 20 years old, studying at one of the most prestigious universities in the world, his future entirely open before him, still had to write it down as a sin to confess. What does that tell us? He could not let it go. He carried it all along. But there is another way to read this. The child who harbored anger strong enough to carry it for 15 years was not a child broken by abandonment. That was a child responding to abandonment, still alive, still angry. And that anger, in the strange case of Isaac Newton, would become the fuel that drove an entire life. Some psychologists have read the Fitzwilliam Notebook as a clinical document. And here is what is interesting. What they find is not the portrait of a person who would become great. They find the portrait of a person enduring a pain he has no language to name, and using the only language available to him in the 17th century, the language of religion, to try to place it inside some manageable framework. Sin was the word he had, but what he was describing was not exactly sin. It was loss, rejection, and most importantly, the absence of the one face a child needs to see in order to understand that they deserve to stay. When Barnabas Smith died in 1653, Newton was 11. His mother returned to Woolsthorpe, this time with 3 young children from her second marriage. And for the first time in 7 years, Newton lived with his mother. But the strange thing, or perhaps not strange at all, depending on how you look at it, is that living together did not heal anything. The years of separation had created a distance that physical closeness could not close. Newton didn't know how to be a son in the ordinary sense. And Hannah, managing 3 young children, a farm, and the estate of a recently dead husband, had no energy left to learn how to be the mother of a distant and unusual child. What is most noteworthy about this period is not what passed between Newton and his mother. It is what Newton found in the library of his dead stepfather. Barnabas Smith, the minister, the man Newton had threatened to burn alive in a childhood memory, turned out to be a serious reader. He left behind a substantial library, and more importantly, he left a large number of blank notebooks. Newton took those notebooks and began to write. This is the moment that, if forced to choose a single starting point for the intellectual career of Isaac Newton, many historians would choose. Not Cambridge, not the plague year, not the Principia, but an 11-year-old boy sitting down with the notebooks of the man he had despised and beginning to fill them with a language of his own. In 1655, at age 12, Newton was sent to the King's School in Grantham, the nearest town with anything resembling proper education. He boarded with an apothecary named William Clark. This was the second time in his life Newton was separated from home. But something was different here. The Clark household was not his cold grandmother's house. There was a laboratory of sorts, or more precisely, a room full of bottles and instruments belonging to a man who worked with chemicals. There were books, and there was Clark's stepdaughter, Catherine Storer, toward whom Newton, by later accounts, appears to have had some feeling, though he never openly acknowledged it. What King's School actually taught Newton, though, was not science. 17th century schools taught primarily Latin, some Greek, and theology. This was the foundation required for university entry. Newton performed well, but not in the way his teachers wanted. There is an account, recorded by one of his schoolmates, saying that Newton would often sit through lectures with a notebook on his knee. But he was not taking notes on the lesson. He was writing down the questions the lesson failed to answer. This is the strangest and most effective learning technique I know of in any historical figure. Not studying what was already known, but listing what remained unknown. Newton did this throughout his life. He called it questiones, Latin for questions. These were notebooks in which he recorded not knowledge, but the boundaries of knowledge, the places where human understanding ended and darkness began. And then he walked into the darkness. In 1659, when Newton was 16, his mother called him back to Woolsthorpe. She had other plans for her son. The farm needed managing. Instead of continuing his studies, Newton needed to learn how to be a farmer. Newton became the worst farmer in the recorded history of Lincolnshire. He had notebooks in his pocket. He had questions in his head. And when the cattle wandered into the neighbour's garden, he didn't notice, because he was working through a geometry problem in the dirt with a stick. He was fined multiple times for allowing livestock to roam freely and damage neighbouring crops. Those penalty records still exist in the local archives. And in another record, from a rural parish council meeting, Isaac Newton's name appears alongside the notation, frequently absent when assigned duties. He was sitting under a tree reading, or drawing figures in the earth, or watching light move through leaves and wondering why those rays were not perfectly parallel. The person who rescued Newton from a life of farming was his own uncle. William Ayscough, a minister who had studied at Cambridge. He saw what Hannah could not see, or chose not to see. His nephew was not a wayward farmer. This was a mind imprisoned in the wrong vocation. Ayscough persuaded Hannah. Hannah agreed, perhaps partly because she was exhausted by the penalty notices. In 1661, Newton, 18 years old, older than most of his peers, set out for Cambridge. He arrived as a sizar, a poor student who waited on the wealthier students at table in exchange for room and board. Even here, even at the threshold of the career that would change the history of human thought, he was positioned at the bottom rung. No one knew him. No one paid attention to him. And Newton, who had spent his entire childhood on the margins of everything, felt completely at ease with that. Trinity College, Cambridge in 1661, was simultaneously magnificent and decaying. Magnificent in the architectural sense. White limestone buildings surrounding a great courtyard, a fountain at the center, a library containing more books than Newton had ever seen in one place. Decaying in the intellectual sense, the curriculum was still built almost entirely on Aristotle. Greek philosophy more than 2,000 years old, being replaced everywhere except in universities determined to preserve it out of tradition. Newton quietly bypassed the official curriculum. He went to the library and taught himself Descartes, taught himself Galileo, taught himself Kepler. These names, for students following the proper course of study, barely appeared in the classroom. But the most important thing he found at Cambridge, the thing that truly opened the door, was not an author or a theory. It was a language, the language of mathematics in its most modern sense. And here is what most people don't know. Isaac Newton was essentially self-taught in mathematics. He arrived at Cambridge without any particular mathematical foundation, and within less than 3 years, he had advanced from basic arithmetic to the outermost frontier of what mathematics could then do, and then gone further. Why did Newton learn so quickly? The answer lies in his method. He did not study mathematics in order to know mathematics. He studied it because he needed it in order to ask questions that no other language could express. About light, about motion, about why things fall the way they fall, and why things in the sky move the way they move, and whether those two things, the falling and the orbiting, might be the same thing. Let us return to the notebook of 1662. Because in the same notebook containing those 47 sins, there is something else. On the cover, written in Newton's hand, in ink now turned brown after 360 years, are 4 words that no one has ever deciphered. Nabed efihik, that is all. 4 syllables, no context, no explanation. Nowhere else in Newton's documents does this combination appear. Scholars have tried. Is this a cipher? A distorted proper name? A word from an unidentified language? An alchemical symbol? No answer has held up. Those 4 words, Nabed efihik, have sat there for 3.5 centuries, on the cover of the sin ledger of the greatest scientific mind in history, undeciphered. And perhaps they will never be deciphered. That is the first thing you should know about Isaac Newton. Even when he confessed, he kept something back. Before this chapter closes, there is one event from Newton's time in Cambridge, around 1663, that I need to tell you about, because it is emblematic of something central to his character, something his later life would repeat in countless forms. Newton wanted to understand how light worked, not theoretically. He wanted to understand it physically, at the level of what is actually happening when light strikes an object and we perceive color. The prevailing theory, from Aristotle refined by Descartes, held that colors were a mixture of light and darkness, that they did not exist within white light. They were produced when pure light came into contact with impure matter. Descartes believed this. Hooke believed this. It was the accepted position. Newton doubted it. Not because he had theoretical reasons. He doubted it because it was too tidy, and he had learned from very early on that nature is not tidy in the ways humans want it to be. He took a large sewing needle, the kind called a bodkin, used for stitching thick leather. He inserted it into his eye socket between the eyeball and the bone, and pressed gently on different parts of the eyeball. Each time he pressed, he saw rings of color and light appear, not because there was light outside, but because the mechanically stimulated eyeball was sending signals to the brain. He recorded every response, the shape of the rings, the position on the eyeball corresponding to the position of the ring in his field of vision, how things shifted as he moved the needle from left to right, from top to bottom. He did this multiple times. To be clear, this was an extraordinarily dangerous experiment. The eyeball is not designed to have a needle inserted into it. Newton was fortunate not to go blind. Or perhaps fortune had nothing to do with it. Perhaps he had calculated the risk and accepted it, because the answer to his question mattered more to him than preserving his own sight. What he learned from this experiment, that light and color are phenomena of the nervous system, not of pure optics alone, would later become part of the foundation of his theory of light. But more important than the scientific result is what it tells us about the man asking the question. Newton put the most important asset he possessed at risk, and did not hesitate. This is what would accompany him throughout his life. Everything could be a subject of experiment. Everything. Including himself. When Cambridge closed in 1665 due to plague, and we will come to that in the next chapter, Newton returned to Woolsthorpe carrying three things: a collection of notes on light and color, a series of unanswered questions about motion and gravity, and a notebook containing 47 sins, along with 4 words no one has decoded. He was 22 years old, had published nothing. No one knew his name. And his mother, the woman whose name appears not in the list of his sins, but in the space around them, in the shape of the absence that made the list necessary, was waiting for him to come home. History would call the period that followed Annus Mirabilis the Year of Wonders. But before the wonders came, there was a summer and a loneliness. And a 22-year-old sitting in the stone house of his dead stepfather, reading back through notebooks written in his own hand, and beginning to understand that the questions he had carried home from Cambridge were not questions about the universe. They were questions about himself. Chapter 2 will take us into that summer of death, 1665 and 1666, when the plague swept through England, and a solitary young man at Woolsthorpe invented calculus, laid the groundwork for modern optics, and began asking questions about gravity, all in silence, with no one around to talk to. If you're listening to this and the story of that abandoned child touched something, if you recognize yourself in the boy sitting in a field with his head full of light while the cattle wandered, leave a comment. I want to know what you see in this story. Nights like tonight, or mornings, or afternoons, are always the best time to look back and ask, what have we been carrying from the past? And can we, like Newton, turn what we carry into fuel rather than weight? That question needs no answer tonight. Let it sit. Until the next chapter. Chapter 2. The Summer of Plague. In 1665, death came to London by sea. They say the ships arriving from Holland carried more than wool and spices. The rats aboard carried fleas. The fleas carried Yersinia pestis, the bacterium that in the 17th century had no name, no visible form, and no explanation for why it killed so fast. By spring of that year, London had begun counting bodies. By summer, the numbers exceeded anyone's ability to count. At the peak of the epidemic, September of 1665, there were weeks that recorded more than 7,000 dead in 7 days within a single city. Mass graves were dug at the edges of town. Houses where someone had fallen ill were marked with a red cross painted on the door, and beneath the cross the words, "Lord have mercy upon us." Cambridge sat roughly 80 miles north of London, far enough that you couldn't see the smoke from the burning pyres, not far enough to stop being afraid. In June of 1665, the University of Cambridge closed its doors. Isaac Newton, 22 years old, packed his books and returned to Woolsthorpe. Here is what the story of the apple never tells you. Newton did not go home to rest. He went home because there was nowhere else to go. And in the emptiness that the plague created, the emptiness of complete isolation, of weeks without anyone to argue with, without lectures to silently critique, without a library to retreat into, something strange happened. Newton began to think, not in the ordinary sense. He thought in the way of someone who has had every external constraint removed, and for the first time in his life has enough time to follow a single idea, all the way to its end, not to the stopping point imposed by a class schedule, but to the natural stopping point of the idea itself. He called these months anni mirabilis, the miraculous years, plural, not singular. Because what happened at Woolsthorpe across roughly 18 months from mid-1665 to early 1667 was not one discovery, not two. It was the foundation of modern physics, optics, and mathematics, all at once by a single person in a stone farmhouse in Lincolnshire, while the world outside was dying. Before we talk about what Newton found, though, we need to talk about how he found it, because the method, the process, the habits, the approach matters more than any specific result. And it was completely unlike anything we typically imagine when we picture genius. Newton did not sit down and have ideas. He sat down and asked questions, and then he sat with those questions, sometimes for days, sometimes for weeks, until the question itself led him to the next question. Not the answer, the next question. There is a collection of notes from this period, which historians of science call questiones quaedam, philosophicae, certain philosophical questions, in which Newton lists more than 40 areas he intends to investigate. Not 40 specific questions, 40 fields, on the nature of matter, on light and color, on space and time, on why the planets move in ellipses rather than straight lines, on why the tides rise and fall. Each field was a dark room. And Newton walked into each one, not with a lantern, but with his hands, feeling along the walls in the dark, until he touched something solid. The first question he went deepest into at Woolsthorpe was not gravity, not the apple. It was light. Specifically, why does white light, when passed through a glass prism, separate into different colors? The answer that everyone accepted at that time was this: glass contaminates light. White light is pure. Color is the product of interaction between pure light and impure matter. Descartes believed this. Hooke believed this. It was the settled position. Newton doubted it, not because he had theoretical reasons. He doubted it because it was too neat. And he had learned very early that nature is not neat in the ways humans want it to be. He had purchased a prism at Stourbridge Fair. Records suggest he bought it before leaving Cambridge, perhaps already intending to experiment with it during the break. He cut a small hole in the wooden shutter covering his bedroom window, a hole just large enough for a narrow beam of light to enter, and he watched. The first thing he noticed was not the colors. It was the shape. When sunlight passed through the hole without a prism, it projected a circle on the opposite wall, as you would expect, since the hole was circular. But when he placed the prism in the path, the image on the wall was no longer a circle. It became a long oblong, roughly 5 times longer than it was wide. This was the detail everyone else had missed. No one had asked why the shape changed. They only looked at the colors and explained the colors. Newton stopped at the shape, and it was the question about the shape that led him to the correct conclusion. White light is not pure light. It is a mixture of many different kinds of light, each bent by the glass at a slightly different angle, which is why the image stretches out, red at one end, violet at the other, because they bend by different amounts. He called that band of color a spectrum, from the Latin for apparition, presence made visible. We still use that word today, but Newton did not stop there. He designed a second experiment, what he later called experimentum crucis, the crucial experiment. He used the first prism to split white light into its colors. Then he placed a card with a small hole in it, so that only one single color, say red, could pass through. He then directed that single red beam through a second prism. If color was created by glass, the second prism should generate more colors from that red beam. Nothing happened. Red stayed red. White light is a mixture. Color is a component, not contamination, structure. This is one of the most important moments in the history of science, and it happened in a bedroom in Lincolnshire, in the silence of a plague year, by a man with no one to talk to. Light, though, was only one of 3 things that happened at Woolsthorpe. The second, which Newton would later describe in a tone so calm it borders on strange, as though he were recounting finding a coin on a path, was the invention of calculus. Calculus, the mathematics of change, the language in which all of modern physics is written. In 1665, a problem existed that had no name yet. How do you calculate the exact speed of a moving object at a single precise moment? Not average speed, instantaneous speed. At the moment a cannonball reaches the top of its arc, what is its velocity? At the point where a curve is touched by a straight line, what is the slope? These questions had no answers in the mathematics of the time because they involved infinity, dividing a number by an infinitely small number. And traditional mathematics had no way of handling infinity. Newton called his method the method of fluxions, the method of flowing quantities. The central idea was this: instead of trying to calculate at an exact moment directly, approach that moment. Calculate over intervals that get smaller and smaller. 1 second, 1/10 of a second, 1,000th, and watch where those numbers converge. Where they converge is the answer. This is the concept of a limit. And from the concept of a limit, he built the entire apparatus of differential and integral calculus in under 2 years. What centuries of mathematics had not accomplished, Newton did in the silence of a plague year. He did not publish it. This is the detail people most often skip when telling Newton's story. And it matters more than most people realize. Newton had a habit of not publishing. He would write, calculate, prove, and then put it in a drawer. Sometimes for years, sometimes for decades. Even the Principia itself, the work that changed the history of science, was only published because Edmund Halley, the man whose name is attached to a comet, travelled to Cambridge, read the manuscript sitting in Newton's drawer, and practically begged him for permission to print it. Why didn't Newton want to publish? Historians have debated this without reaching a definitive answer. But there is one theory. Not about modesty, not about scholarly caution, about something deeper. Newton was afraid of criticism, not in the ordinary sense, not afraid of being told he was wrong. He was afraid of something worse, afraid of being questioned, afraid of having to defend himself, explain himself, persuade. He wanted truth to be truth, not argument. And when he understood that the scholarly world does not work that way, he chose not to participate in the scholarly world, at least until he had no other choice. And then there is the third thing, the one every textbook tells, but usually tells wrong, the apple. Let me be clear about this. The apple is real, or at least there is enough evidence to reasonably believe that some event involving an apple and Newton at Woolsthorpe actually occurred. The first person to record the story, William Stukeley, Newton's friend and biographer, heard it directly from Newton himself when the man was already old. The account was set down in 1726, 1 year before Newton died. But here is what Stukeley actually recorded. Not the version textbooks compress into a single sentence. Newton said he was sitting in the garden drinking tea when an apple fell. And the question that arose in his mind was not, why does the apple fall down? That question was too simple. Everyone knew apples fell because they were heavier than air. The real question, in Newton's own telling, was, why does the apple always fall perpendicular to the ground? Why not sideways? Why not upward? And from that question, not from the impact of the apple, he began thinking about gravity as a force with a direction, a center, acting across distance. Here is the leap. Before Newton, most people thought of gravity as a property of objects, something inside the apple that caused it to fall. Newton asked, what if this force is not inside the apple, but between the apple and the earth? If the earth is pulling the apple toward it, then the apple is also pulling the earth toward it. It's just that the earth is too heavy for us to notice the movement. And if so, if the force between the earth and the apple operated on that principle, then why wouldn't the same force operate between the earth and the moon? Why doesn't the moon fall down like the apple? The answer Newton eventually arrived at, and this took not one afternoon but many months, was, the moon is falling. It is simply moving sideways fast enough that by the time it falls, the surface of the earth has curved away beneath it. The moon is falling continuously and continuously missing the earth. That is an orbit. And if that was true, then the force holding the moon in its orbit was the same force that had pulled the apple to the ground. Not two different forces. The same force, operating at different distances, diminishing in proportion to the square of the distance. The law of universal gravitation. Not a moment, but a process. Not one night, but months of silence. And all three things, optics, calculus, gravity, happened within the same 18 months, in the same house, by the same 22-year-old man. But there is something that this Woolsthorpe period does not reveal, something that would only surface decades later, about what else Newton was reading while all of this was happening. In his notebooks from this time, alongside the equations and the optical experiments, there are notes on something else entirely. Alchemy, not as historical curiosity, not as an outside observer, but with the same intensity and the same level of detail he brought to light and motion. He was reading Paracelsus, reading Michael Meyer. reading alchemical texts whose authors were not even clearly identified. And he was not reading them as a skeptic. He was reading them as someone searching. Searching for what? That is the question we carry into the chapters ahead. Because to understand Isaac Newton, not the myth, but the man, you have to hold two images in your mind at the same time. On one side, the man who placed a prism before sunlight and asked completely rational questions about the nature of color. And on the other, the man who read texts about transforming metal into gold and asked, with exactly the same seriousness, could this be real? In 1667, the plague retreated. Cambridge reopened. Newton returned to the university and was elected a Fellow of Trinity College. A stable position, a regular income, guaranteed lodging. He carried with him everything he had done in those 18 months. And he continued to tell no one, not because he wasn't ready, but because he had learned something about himself in those quiet months at Woolsthorpe. He worked best when no one was watching. Solitude was not something he endured. It was something he required, and that, the need for invisibility, for a private darkness no one could enter, would be the thread that led him into the next room, the room with the furnace, the glass vessels in colors like illness, the smell of sulfur and mercury, and things that had no name in the language of science. Chapter 3 takes us into that laboratory, into the alchemy years at Trinity College, where Newton searched for what no equation could find for him. If you're somewhere in the night right now, while the city outside sleeps or stays awake without you, consider this question. Is there something you know with certainty is true, but have never said out loud to anyone? Not because it's a secret, but because you haven't yet found language precise enough to speak it. Newton had a drawer full of things like that. We will open them one by one. Chapter 3. The Burning Laboratory at Trinity. There is a room at Trinity College, Cambridge, that no one was permitted to enter. Not because it was locked, not because there was a sign forbidding it, but because the man who occupied it, Isaac Newton, Lucasian Professor of Mathematics, Fellow of the Royal Society, the man whom all of Cambridge had begun to regard with a careful kind of reverence, had made clear through the sheer force of his manner that his privacy was not a preference. It was a condition that was not open to discussion. From the window of that room on the winter evenings, smoke escaped. Not the smoke of coal, not the smoke of wood. Something else, heavier, with a pale yellow edge, carrying a smell that students passing below could not precisely name but would never forget. Sulfur burning, mercury evaporating. And inside, the thin man with white hair falling to his shoulders was doing something that, if his colleagues had known, most of them would have taken as final proof that genius and madness share a wall with no insulation between them. He was trying to find the secret of the universe inside metal. Before we enter that room, there is a question worth stopping at, one that most people never think to ask. Why would a man who had just discovered how light works, invented calculus, and laid the groundwork for the theory of gravity turn toward alchemy? The easy answer is, the 17th century had no clear boundary between science and the occult. Newton was a man of his time. He could not escape the intellectual limits of the century he lived in. That answer is not wrong, but it is incomplete, because Newton did not come to alchemy out of ignorance. He came to it because he had too many questions, specifically this one. If gravity operates across distance, if the Earth pulls the moon without a rope, without contact, without any visible mechanism, then what is carrying that force? Newton's physics described how things attract one another, It did not explain why. And that gap, the gap between description and explanation, was the space Newton went looking to fill inside alchemy. He was not lost. He was asking the right question. He was simply looking in the wrong place. Newton began seriously studying alchemy around 1668, 1 year after returning to Cambridge from Woolsthorpe. And from that point until roughly 1696, nearly 30 years, he maintained a working laboratory continuously within the grounds of Trinity College. 30 years, without significant interruption. Running in parallel with everything else he did. Historians have counted more than 1 million words in the alchemical manuscripts Newton left behind. Experimental records, translations from other authors, and his own private thoughts on the meaning of what he was doing. For comparison, the entire Principia Mathematica contains roughly 500,000 words. Newton wrote about alchemy more than twice as much as he wrote about his most famous scientific work. The laboratory itself was built in the Garden of Trinity, a small structure of wood and brick, far enough from the main building that the fumes wouldn't drift directly into his colleagues' rooms. The central furnace was called an athanol, from the Arabic, meaning a furnace capable of maintaining a stable temperature over long periods without constantly adding fuel. This was the critical element of practical alchemy. Many processes required stable heat sustained for days, sometimes weeks. The practitioner had to stay close to the furnace, had to check it constantly, had to remain awake when necessary. Newton remained awake. Many nights, many weeks, and according to some accounts left by people who knew him during this period, there were stretches when he barely left the laboratory for days at a time. Meals gone cold on the table, untouched. Coffee, the fashionable new drink spreading through Cambridge, cooling in its cup beside the bubbling glass vessels. A man named Humphrey Newton, no relation, only the same surname, served as Newton's secretary during the 1680s and later recalled he had never once seen Newton laugh, never seen Newton rest in any real sense of the word. But what struck him most was this. During the most intensive periods of experimentation, Newton seemed not to need sleep, or did not know that he needed it. So what was Newton actually doing in that laboratory? The answer is far more complex than the familiar image of alchemy. A man boiling random mixtures and hoping gold appears. Newton approached alchemy as a rigorous discipline. He read everything he could find. And this was not easy, because alchemical literature is famously coded to an extreme degree. Authors deliberately concealed their actual processes behind symbolic language, behind names like Green Lion, the Net, Philosophical Mercury, the Red Man and the White Woman. No one wrote plainly heat mercury to 300 degrees. They wrote, let the green lion devour the sun. Newton decoded backwards. He built a reference table mapping alchemical symbols to their actual chemical equivalents, and then he ran experiments according to what those translations indicated. This is what is remarkable when you actually look at his notebooks. Newton's alchemical work has the same level of precision and systematic organization as his optical work, the same kind of records, the same method of posing questions and testing answers, the same patience in repeating experiments until results were consistent. He did not believe blindly. He investigated. Among everything Newton focused on, two processes drew him back again and again. Both involved mercury, and both would leave consequences he did not recognize until it was far too late. The first was what the alchemical text called the net. This process involved creating a compound from mercury and several other metals, primarily antimony and sulfur. in specific ratios under specific temperature conditions. When successful, the product formed a crystalline branching structure, a lattice of metal that looked like a web. And this, according to alchemical thinking, was evidence that metal was alive, growing like a living organism. Newton was consumed by this idea, not in the mystical sense, but in the intellectual sense. He believed that if metal could self-organize into complex structures, that might offer a clue about the invisible organizing force operating in nature. The same kind of invisible force that troubled him in physics. Alchemy, for Newton, was not the occult. It was an experimental discipline investigating forces he had no name for yet. The second was Diana's tree, Arbor Dianae in Latin. This was a more specific process. Dissolve silver in dilute nitric acid, add liquid mercury and a small amount of acid, and allow it to cool slowly. If the ratios and temperature were right, what happened next appeared impossible. From a clear liquid, metallic branches began to grow, slowly, step by step, dividing like the limbs of a tree, until a three-dimensional structure appeared that looked exactly like a tree made of silver and mercury. Today we recognize this as electrochemical deposition, a completely explicable chemical process. But in the 17th century, watching metal grow from liquid with no seed planted, no light, no soil, it was one of the most staggering things a person could witness in a laboratory. Newton watched it many times and recorded his observations. He wanted to understand the organizing principle behind the phenomenon. What was telling the silver atoms to arrange themselves into that structure? Why not randomly? Why always a tree? That question, why nature tends toward organization rather than chaos, remains one of the central questions of modern physics and biology. Newton was asking it in the wrong language. But the question itself was right. Now I need you to pay closer attention for a moment. Because in Newton's experimental records that for centuries only a handful of scholars were permitted to read, there are lines describing his methods of working with chemicals that, when read with modern medical understanding, produce a particular kind of unease. Newton regularly tested experimental results by smelling and tasting samples. This was not unusual by 17th century standards. It was the normal way of assessing chemicals before modern measuring instruments existed. Bitter or sweet, the smell of burning or the smell of rot. All of it was data. The problem is that Newton worked primarily with mercury, and several of the mercury compounds he used most frequently, particularly mercury chloride, also known as calomel, and mercury sulfate, are acutely toxic even in small amounts. Mercury vapor accumulates in enclosed air, especially when a furnace is burning at high temperatures, especially when you spend days at a time in that room without leaving. In 1693, Isaac Newton, by then 50 years old, at the height of his scientific reputation, suffered a mental breakdown that historians are still debating the cause of. He wrote confused, furious letters, then letters of apology with no clear reason. He described insomnia so severe he could count on his fingers the nights he had slept across entire weeks. He reported going days without eating without realizing it. We will return to that collapse in a later chapter, because it involves more than toxicity alone. But there is this. In the late 20th century, a group of researchers analyzed samples of Newton's hair preserved in the collections of Cambridge University Library. They were looking for traces of heavy metals. The results showed mercury levels in Newton's hair approximately 7 times higher than normal, along with unusual concentrations of lead and antimony. There is no direct proof that mercury poisoning caused the breakdown of 1693. But the symptoms he described, insomnia, pathological anxiety, failing memory, uncontrollable agitation, mapped precisely onto the documented symptom profile of chronic mercury poisoning. Newton had likely been poisoning himself for 30 years, and he did not know. This is the moment worth pausing at, worth sitting with for a little while. This man, who understood the motion of planets, who knew what light was made of, who built the mathematical foundation we still use today to calculate the orbits of satellites, did not realize that Mercury was slowly destroying his nervous system. There is a quiet sadness in that, but also something true about the nature of understanding. We are often most blind to what is closest to us. Newton saw clearly across millions of miles. He could not see what was happening inside his own body. Returning to the laboratory now. Returning to those nights with the furnace burning and the glass vessels and the questions about the nature of matter. During the 1670s, Newton began asking himself an increasingly specific question. Not can gold be made from other metals? That question, he suspected, might have no practical answer. But what makes a substance the particular substance that it is? In other words, why is gold gold? Not because of color. Color is surface. But why does gold resist corrosion while iron does not? Why is mercury liquid at room temperature while iron is solid? Why do different metals have entirely different properties? Not different in degree, but different in kind. That question, why substances differ in quality and not merely in quantity, would not be fully answered until the 20th century, with the development of quantum mechanics and the understanding of atomic structure. Newton was asking the right question 300 years before the tools existed to answer it. That does not make his alchemy less wrong, but it makes him far less deluded than he is usually portrayed. There is a document Newton wrote during this period, never published, discovered in the pile of papers his estate sold at auction after his death, that the economist John Maynard Keynes, who bought many of those papers in 1936, read and then used to offer what I believe is the most precise description of the real Isaac Newton ever written. Keynes wrote, "Newton was not the first of the age of reason. He was the last of the magicians, the last of the Babylonians and Sumerians, the last great mind which looked out on the visible and invisible world with the same eyes, with the same combination of wonder and exact observation, with the same belief that all nature could be resolved, if only one could find the key, the last magician." That is how Keynes saw Newton after reading the pages that were never meant to be printed, and I think it is one of the most accurate things ever said about who Isaac Newton actually was. The laboratory at Trinity continued until around 1696, when Newton left Cambridge for London to take up the position of Warden of the Mint. He did not dismantle it. He simply closed the door and walked away. No one knows what he found, or did not find, in those 30 years. But one thing we do know. Until the end of his life, even after he had become Sir Isaac Newton, President of the Royal Society, the most famous man in England, he kept the alchemical notebooks, did not destroy them, did not give them away, kept them, as though something in those pages contained a question he was not yet ready to release. Some answer he still hoped. After 30 years, after the plague, after the Principia, after everything, might be there waiting for him on some evening when he finally sat down in the right state of mind to see it. The invisible force holding atoms together, the organizing principle behind the silver tree growing from liquid, the bridge between what equations could describe and what reality actually was. He never found it in alchemy, but he never fully believed it wasn't there. Chapter 4 steps out of the laboratory and into a different kind of conflict entirely. Not a battle with matter, but a battle with a person. With Robert Hooke, whom Newton despised with a feeling strong enough to sustain across decades and cold enough to never once be spoken directly. And it brings us to the story behind the most famous sentence Newton ever wrote. Standing on the shoulders of giants, which many people do not know, may not have been a compliment at all. It may have been a perfectly disguised insult, aimed with the precision of someone who had spent a lifetime learning how to wound without leaving a mark. If tonight you are somewhere quiet enough to hear your own thoughts, ask yourself this before you sleep. What are you spending your energy searching for that you don't yet have a name for? Newton searched for 30 years and did not find it. But the questions he asked in the process of searching changed science more than most other people's answers ever did. Sometimes the question matters more than the answer. Sometimes the searching, even the searching that finds nothing, is the only thing that truly lasts. Chapter 4. The War of Ghosts. There are enemies you shout at directly, and there are enemies you never look straight in the eye. But every time you sit down to write, every time you put pen to paper, their face is still there, at the edge of your vision, like a smudge on glass you cannot wipe clean. Robert Hooke was the second kind of enemy for Isaac Newton, and that is why the war between them lasted not a few years, but nearly an entire lifetime, because that kind of hatred, cold and controlled and never once spoken plainly, outlasts any open conflict. It needs no fuel from outside. It feeds itself. To understand this war, you first have to understand who Robert Hooke actually was. Not the faded version history has left us, but the real man. Robert Hooke, born in 1635, was one of the most flexible and wide-ranging intellects of the 17th century. He was the first person to observe cells through a microscope and give them their name. The word cell in biology comes from him. He developed the theory of elasticity that still bears his name today, Hooke's law. He designed instruments, built telescopes, studied fossils, proposed a theory of light, and was involved in redesigning London after the Great Fire of 1666. Hooke worked like a man who knew he had less time than others. And in a sense that was true. He was born with a body that did not cooperate, a curved spine, a small frame, chronically poor health. Everyone who described him mentioned his appearance, not with cruelty, but with the plain-spoken honesty of a century that had not yet learned to pretend not to notice. And here is what matters. Newton noticed too. They met formally for the first time in 1672, when Newton submitted his first paper to the Royal Society, a paper on his theory of light and colour, the result of the prism experiments at Woolsthorpe. This was Newton's first public submission of anything, and he chose not calculus, not gravity, but light, the thing he felt he had proven solidly enough that no one could attack it. He was wrong. Hooke, at that time serving as the curator of experiments for the Royal Society, the man responsible for evaluating submitted papers, read Newton's work and wrote a long response. Much of it was reasonable. Technical questions about method, points requiring clarification. But the most important part was not reasonable at all. Hooke declared that Newton's theory contained nothing new, that he himself had already considered similar ideas, and that Newton's experiments were insufficient to support the conclusions Newton had drawn. Newton read that response and was silent for 3 weeks. Then he replied, in a long, careful document so cold that finishing it leaves you reaching for a warmer room. He dismantled every one of Hooke's points, not with anger, but with the surgical precision of a man removing weak arguments one by one in sequence. And at the end, after negating everything Hooke had said, he wrote the usual courtesies about mutual respect. That was how Newton fought, never shouting, always formally polite, and ruthless in content. But that first wound, even though Newton won the exchange on paper, did something to him. It confirmed what he had always suspected, that the scholarly world was not a place for finding truth. It was a place for fighting over the ownership of truth. Newton retreated. For years afterward, he declined to engage in public debates. When asked about his work, he responded with carefully engineered vagueness. He continued researching alchemy, theology, mathematics, but he did so in his self-imposed darkness, sharing nothing, publishing nothing. Edmund Halley, the man who would later persuade Newton to publish the Principia, described approaching Newton like approaching an extremely intelligent wild animal. You had to move slowly, avoid direct eye contact, avoid questions that were too pointed, and hope that today happened to be a day he was willing to be seen. The tension between Hooke and Newton boiled over a second time in 1679, when Hooke, then working to construct his own theory of planetary motion, wrote to Newton asking his opinion on a specific idea. Could the motion of planets be described as a combination of a tangential force and a force directed toward the sun? This was an important question, and Newton, who had been thinking about exactly these problems for years but had never published, replied in a way that was deliberately vague and unhelpful. But during that exchange of letters, Hooke proposed one specific detail. He believed gravitational force decreased with the square of the distance, meaning if you double the distance, the force dropped to 1/4. Newton did not address that point in his reply, but he recorded it in his notebook, and years later, in the Principia. The inverse square law appeared, fully proven, built into a complete theory, without Hooke's name anywhere in the acknowledgements. This is the point where history becomes uncomfortable. Hooke was not the only person who had thought about the inverse square law before Newton. Christopher Wren and Edmund Halley had discussed similar ideas, but none of them could prove it. No mathematics, no calculus, no way of connecting that intuitive idea to the actual observed motion of planets. Newton had calculus. Newton had the proof. And by the strict logic of scholarship, the person who proves a theorem owns it, not the person who guessed correctly but could not demonstrate it. That is technically true, but it leaves something out. Hooke had pointed the direction, and Newton, who had recorded that suggestion in his own notebook, did not acknowledge it. When the Principia was published in 1687 and became the greatest scientific event of the century, Hooke publicly protested that Newton had taken his idea without credit. Newton responded by removing Hooke's name from the next edition of the Principia, not only from the disputed section, but from other places in the book where he had previously mentioned Hooke in neutral terms, a name erased from the most important work of the century, not because it was wrong to include it, but because Newton was angry. And now the story of the shoulders of giants. In 1676, in a letter written to Robert Hooke, written during a period when the two men were making a temporary attempt at reconciliation, after the dispute over light, Newton wrote the following: "If I have seen further, it is by standing on the shoulders of giants." This sentence has become one of the most quoted in the history of science. It is carved into the walls of universities, printed on T-shirts, cited in thousands of graduation speeches as a symbol of intellectual humility, of acknowledging that no genius operates in a vacuum. that every great idea stands on the foundation of ideas that came before. But there is something that most people who quote that sentence do not know, or choose not to know. Robert Hooke was short, his spine was curved, his frame was small. And in 17th century English, when Newton used the word giants in a letter written directly to Hooke, a man whose small and bent body was known to everyone in the academic communities of Cambridge and London, no one reading it could fail to catch the second layer of meaning. I stand on the shoulders of giants, sent to a man who was not a giant, written by a man in active dispute over intellectual ownership with that same man. This is where I need to be honest with you. We cannot know for certain. There is no absolute proof that Newton used that line as a deliberate insult. The phrase itself also appears in literature predating Newton. The 12th century theologian Bernard of Chartres is credited with a similar idea long before. Newton may simply have been quoting a familiar metaphor. But consider what we need to place side by side and allow you to reach your own conclusion. Newton knew exactly who he was writing to. Newton possessed a memory and a precision with language that were both extraordinary. Every word he used was weighed. And Newton, as we have seen across his dealings with Hooke over multiple decades, never attacked directly. He attacked in ways the target could not prove were attacks. History records it as a statement of humility. Hooke, if he read it the second way, had no means of objecting without making himself look foolish. The genius of Newton was not confined to his equations. This war continued until Hooke died in 1703, and the most notable thing happened immediately after that death. 1 year after Hooke was gone, Newton was elected president of the Royal Society. In the first weeks following his inauguration, a portrait, the only portrait of Hooke that had ever been painted, which had hung in the Royal Society building, disappeared. No official order, no record of it being moved or destroyed. It simply was not there anymore. To this day, no portrait of Robert Hooke survives. We do not know what he looked like. Some historians believe this was coincidence. Buildings were rearranged. Artwork was misplaced in the process. These things happen. Other historians, working from context, from timing, from what they know of Newton's character, believe something different. And once again, you have enough information, you decide. But I want to stop here and say something about what this war actually was. Not about who was right or wrong in the scientific dispute, but about what it reveals concerning Newton himself. Some people will read this story and see Newton as the villain, the man who erased a colleague's name, the man who may have mocked another's physical appearance, the man who sustained a cold grudge across decades. And those things are not factually wrong. But there is another way to read the same story. This is a man who was wounded very early by rejection, who had learned, from the time he was a 3-year-old sent across the road to his grandmother's house, that the world is not automatically safe, that the people most capable of harming you are often the ones you least expect. That man, when he stepped into the scholarly world carrying the first work of his life, and was immediately criticized by someone with more power, responded the way the child inside him had learned to respond. Withdraw, go silent, and remember. This does not justify erasing anyone's name. Nothing justifies that. But it explains why. And sometimes understanding why matters more than judging who. There is a small detail from Newton's life during this period that I find worth telling. During the years of conflict with Hooke, the years when Newton was simultaneously not publishing and not fully going quiet, simultaneously furious and unable to show that fury, he began spending more time in the alchemy laboratory. And in the records from this period, one detail appears repeatedly. He was particularly interested in compounds that produce sound when heated, reactions that made small popping noises, hissing, the clicking of crystals forming. Why did that interest him? We don't know. He never explained it. But I see in that detail the image of a man finding release in the laboratory, in those small controlled explosions and that managed hissing, for things he would not allow himself to release in any other way. The war with Hooke ended not through reconciliation, not through one side admitting anything, but through the death of one side and the erasure that followed. Newton won, in the most ordinary sense of that word. But the cost of that victory, 30 years of carrying cold hatred, 30 years of everything filtered through the lens of defensiveness and suspicion, is not found on any page of any textbook. Newton lived a long time, 84 years, a remarkable lifespan for any century, and particularly striking for the 17th. With all the mercury he had inhaled, in those years he achieved everything a human being could achieve in science and in society. But he lived alone, never married, no children, no true friends in any sense the word usually carries, only colleagues, students, and enemies. And sometimes the line between all three was not clear. There is a question I do not have an answer to, and I think no one does. Did Newton ever regret that? The cost of it? He left more than 1 million words in his manuscripts. Not one of them is an answer to that question. Chapter 5 steps out of the laboratory, out of the study, out of the scholarly battles, and takes us into the most dangerous thing Newton ever did. Not dangerous in the physical sense, not in the sense of his health, but in the social and legal sense of the 17th century. He spent decades trying to prove that the Christian Church had built its entire theology on a historical lie, that the Holy Trinity, the central doctrine of Christianity, was the product of forged texts and political manipulation in the 4th century, not the original teaching of Jesus. He believed this with the certainty of a man who had examined the evidence, and he kept it secret with the caution of a man who knew that in the 17th century, that belief could destroy him. If you are somewhere tonight and the story of Newton's war with Hooke has touched something familiar, about relationships you never resolved directly, about things you chose silence over honesty for, leave a comment. I find myself wondering how many of us recognize that kind of fighting in ourselves. No shouting, no direct attack, just remembering and waiting. Chapter 5. Arian Heresy, the Deadly Secret. There are secrets people keep out of fear, and there are secrets people keep because they have not yet found anyone worthy of hearing them. Isaac Newton kept the greatest secret of his life for nearly 50 years, not because he was weak, not because he was uncertain, but because he understood better than anyone that in the 17th century, there were truths that, if spoken aloud in public, would not end in debate. They would end in the loss of everything: position, reputation, freedom, and in the worst cases, life itself. The secret was this: Isaac Newton believed that the Holy Trinity, the most foundational doctrine of Christianity, the concept that Father, Son, and Holy Spirit are 3 persons within one God, was a fraud, not a theological misunderstanding, not a differing interpretation, but a deliberate fabrication, engineered by ambitious men in the 4th century, reinforced through political violence, and passed down as sacred truth across 14 centuries that followed. He spent approximately 1,200,000 words trying to prove it, more than anything else he ever wrote, and he did not publish a single word of it while he was alive. To understand why this was so dangerous, we need to step back into the context of 17th century England for a moment. After the Protestant Reformation, after the Civil War, after Charles II returned to the throne in 1660, England existed in a state of extreme religious sensitivity. The Church of England was the state church. To hold a position at a university like Cambridge, you had to be a member of that church. To become a full professor, you had to swear an oath before the Holy Trinity. There was an Act of Parliament, the Blasphemy Act of 1697, stating that anyone who denied the doctrine of the Trinity could be stripped of every civil and religious office they held. And in the decades before that, some people had been executed for the same category of heresy. Newton knew all of this, and he continued researching, continued writing, continued digging deeper into the evidence. With the composure of a man who had decided that truth mattered more than safety, as long as that truth was never spoken aloud. Newton's theological journey did not begin from skepticism or rebellion. It began from the same place everything else about him began, from a question. In the 1670s, while preparing to receive his full fellowship at Trinity College, a position requiring ordination as an Anglican minister, Newton began reading the Bible again, not as a believer reads it, but as an investigator, with the same analytical stance he brought to alchemical texts, the same intolerance for logical inconsistency and internal contradiction. And he began noticing things that did not sit right. Specifically, the passages of Scripture used to prove the doctrine of the Holy Trinity, the most important passages, the most frequently cited in sermons, the ones constructed as the foundation of all Christian theology, looked wrong when he compared them across different ancient manuscripts. He began learning Hebrew, learning ancient Greek, tracking down the oldest manuscripts he could find, and comparing them word by word, line by line. What he found kept him awake, not in the metaphorical sense, but in the literal one, because Newton already slept little, and during periods of intensive theological investigation, those around him noted he was staying up until morning more frequently than usual. He found evidence, in his view clear and irrefutable evidence, that several of the most pivotal passages in Scripture, the very passages used to prove the divinity of Jesus and the doctrine of the Trinity, had been added later, not faithfully transmitted from their original source, but inserted by scribes or translators deliberately or under the theological influence of their era. Two passages haunted him above all others. The first was the Comma Johanneum, a line in the first epistle of John, chapter 5, verse 7, which contains an explicit reference to the Father, the Son, and the Holy Spirit as three in one. This was one of the most cited passages in all of Trinitarian theology. Newton discovered that it does not appear in the oldest Greek manuscripts. It appears only in later Latin translations, and even there, only in some versions, not all. The second was a line in the first epistle to Timothy, chapter 3, verse 16, where the standard translation reads, "God was manifest in the flesh," but Newton found that in the older manuscripts, the word used was not God. It was he, who, or the one who, a neutral term that does not assert divinity. One word changed, a single word that without knowing the history of the text, you would never catch. But that one word was the foundation of a significant portion of Western Christian theology about the divine nature of Jesus. Newton wrote about these findings in a long document, later called Two Notable Corruptions of Scripture. He sent it to the one trusted friend he had, John Locke, the philosopher, whom he knew was careful enough not to circulate it widely. Locke proposed publishing a French translation in Holland. Further away, legally safer. Newton panicked. He wrote back immediately demanding Locke do no such thing. And here is what is worth noting. He did not say because the idea is wrong. He said because the time is not right. He knew he was correct. He simply could not live in a world where being correct was permitted. But two notable corruptions was only the surface. Behind it lay a vast theological project Newton had been accumulating for 40 years. Hundreds of thousands of words analyzing church councils, the history of doctrine, biblical manuscripts, and the early fathers of the church. And the central conclusion of all of it was a theological position known by a specific name: Arianism. Arius was a priest in Alexandria in the 4th century who taught that Jesus was a being created by God the Father, not co-eternal with the Father from everlasting eternity. According to Arius, Jesus was divine in some sense, but not equal to God the Father, not God in the full and absolute meaning of that word. In 325, at the Council of Nicaea, the first great council of the Christian Church, Arius's position was rejected and condemned as heresy. The doctrine of the Trinity was formally established. Those who disagreed were sent into exile. Newton read the record of that council, read the debates, the correspondence, the accounts of how the votes were conducted, and he concluded that the outcome of the Council of Nicaea was not revealed theological truth. It was the result of politics, of imperial pressure, of men fighting for power rather than for truth. To understand how Newton argued this, you need to understand his method, because this was not emotional theology. This was forensic investigation of ancient texts, performed with the same precision he brought to mathematical equations. He classified sources by chronological order. He noted every point where different manuscripts contradicted one another. He traced each small change in the text across centuries and asked, who made this change? At what moment? And what was happening inside the church at that moment? He found a pattern. The largest changes, the most significant additions, clustered around the period from the 4th to the 5th century. Precisely the period when Trinitarian doctrine was being debated, consolidated, and imposed. And he posed a question in a way that no one in the 17th century dared commit to paper. If the doctrine of the Trinity is a truth revealed by God, why does it require human beings to add things to Scripture in order to prove it? The strange and important thing to emphasize here is that Newton was not an atheist. Quite the opposite. He believed in God with absolute certainty, not because he had been taught to, but because he looked at the universe and could not explain its order in any other way. In the Principia, he wrote that the solar system could not have arisen from natural laws alone without intelligent design. This was a man who had found those laws, and still believed that behind the laws was a mind. Newton believed in God so profoundly that he could not accept a God built on a foundation of lies. It was precisely because he loved God that he could not accept the Trinity. This is the reversal that many people miss. Newton's theological research was not a sign of someone losing faith. It was the act of someone trying to protect his faith from what he believed had corrupted it. Newton's Arian conviction had one very specific and very dangerous practical consequence. It meant that his entire position at Cambridge was resting on false ground. The Lucasian Professorship of Mathematics, the most prestigious position at Cambridge, the one he had been appointed to in 1669, required its holder to be ordained as an Anglican minister within 7 years, and ordination required swearing allegiance to the doctrine of the Trinity. Newton could not swear that honestly. He believed it was wrong, but he also could not refuse to swear without explaining why. And explaining why meant exposing his beliefs. This was a problem without a conventional solution. And Newton solved it in the way that, once you know his character, becomes entirely predictable. He looked for an administrative exit. In 1675, with the 7-year deadline approaching, Newton wrote a petition to King Charles II, requesting an exemption from the ordination requirement for the Lucasian professorship. The reason he gave had nothing to do with theology. He did not mention theology in a single word. The reason he gave was practical. He argued that requiring a mathematics professor to be a minister was inconvenient, that the two professions did not necessarily need to be combined. King Charles II, who had many more pressing concerns than whether a mathematics professor needed to be a minister, approved the petition. From that point on, the Lucasian professorship did not require ordination. That exemption remains in effect to this day. Newton's successors, William Whiston, and many who followed, including most recently Stephen Hawking, all benefited from it. None of them knew why it existed. Newton changed a university regulation by never once stating the real reason why, but the theological problem did not disappear simply because he had found an administrative escape. In the decades that followed, Newton continued writing, continued going deeper into church history, into the councils, into the specific individuals he identified as responsible for what he called the Great Apostasy, the moment when the Christian church had been led away from the original teachings of Jesus and redirected by men with political ambitions. The central figure in his analysis was Athanasius, Bishop of Alexandria, the main opponent of Arius at the Council of Nicaea, and the man later canonized as a saint by the Church. Athanasius, according to Newton, was the architect of the deception, not necessarily because he was an evil man, but because he was the man who won, and winners write history. Newton analyzed the career of Athanasius the way he analyzed a chemical reaction, with patience, with attention to detail, and with conclusions drawn from evidence rather than belief. There is a passage in Newton's theological manuscripts, a passage the historian Frank Manuel quoted in his landmark biography, in which Newton describes the condition of the Church after the Council of Nicaea in language that is almost apocalyptic. He writes of a church that had been corrupted by idolatry, by the doctrines of devils, by compromise with worldly power. This is not neutral historical language. This is the language of a man who is angry. And I think that anger, Newton's fury at what he believed was institutionalized dishonesty, came from the same source as every other anger in his life, an absolute intolerance for dishonesty, whether that dishonesty appeared in Hooke's criticism of his work or in the texts of the Church Fathers on the nature of God. Newton could live with not knowing an answer. He could not live with accepting a wrong one. In 1690, Newton came close to accidentally revealing his position to someone. That person was John Locke, the philosopher, his most trusted friend in that period, the man to whom he had already sent the two notable corruptions manuscript. In a series of letters exchanged between them, Newton wrote about his theological findings with a degree of detail and openness beyond anything he had written for anyone else. Those letters, reading them today, have the quality of a man temporarily released from the burden of having to stay silent. He argues, he analyzes, he points out contradictions in the biblical text with the enthusiasm of someone who has been waiting far too long to speak. And then he realized he had said too much. We know this because after 1690, those letters became shorter, more guarded. Newton began referencing theology indirectly, not refusing to speak, but speaking in ways that if someone read them without permission, they could not be entirely certain what he was actually saying. The cold of self-censorship returned, and it never fully thawed again. There is a detail from Newton's later life that few people know about, and that I find to be one of the most quietly striking of all. In 1705, Newton was knighted, Sir Isaac Newton, by Queen Anne. This was the highest form of social recognition, the moment when a farmer's son from Lincolnshire became a member of the English nobility. The ceremony was held at Trinity College, the very place where for 30 years before he had been quietly building the case that the doctrine named after the college itself, the Trinity, was a historical lie. He knelt. He received the sword lightly on his shoulder. He stood with a new title, and no one in that room knew what he actually believed. Finally, when Newton understood he was close to death, in early 1727, when his health had visibly failed, there is a detail that those around him recorded. He refused to receive Holy Communion before he died. This was an extraordinarily unusual refusal for an Anglican of the 18th century. The Eucharist was the central rite of the Christian death in that era. Refusing it was not something a person did casually or without thought. Newton did it in silence. No explanation, no declaration. Simply refused and lay down to wait. What he thought in those final hours, facing the God he had spent his entire life both serving and arguing with, we do not know. No one was close enough to ask. And even if they had asked, he likely would not have answered. There are secrets people carry all the way to the end, not out of fear, but because they are theirs and they choose to keep them that way. Before we move forward, though, I want to leave you with this. Newton was not the first and will not be the last person to stand inside an institution while secretly believing that the foundations of that institution were wrong from the beginning. What he did was not sabotage, not abandonment, but continuing to live and work in a world that was not entirely the world he wanted, while keeping for himself, in a locked drawer, a different portrait of that world. Was that wisdom or cowardice? Pragmatism or the slow loss of oneself? That question has no definitive answer. And Newton, who spent his whole life with questions that had no definitive answers, would probably not be surprised to find that the questions about himself belong to the same list. Chapter 6 will take us into a different dimension of that same theological question. Not the question about the nature of God, but the question about the house of God. Newton spent years analyzing the dimensions of the Temple of Solomon, the temple that the ancient Israelites believed had been built according to a design from God himself. He did not do this as an archaeological exercise. He did it because he believed that within those numbers, within the specific dimensions of the rooms and corridors and inner courtyards of that ancient temple, God had hidden something, a constant, a code, a clue about the structure of the universe. The man who discovered the law of universal gravitation was searching for a cosmic constant inside the architecture of a temple destroyed 2,000 years before he was born, and he was doing it with mathematics. If you are somewhere tonight, holding a belief or carrying a question you have never spoken aloud because you haven't found anyone worthy of hearing it, leave some sign of that in the comments. You don't have to say what it is. Just let it be known that you are here, listening, carrying something of your own. Newton was not alone in that, and perhaps neither are you. Chapter 6. The Architect of God. Imagine you are holding a piece of old vellum, the kind made from goat skin, tanned and stretched and dried until it is thin enough for candlelight to pass through. On it are numbers, hundreds of numbers arranged into tables with margin notes in Latin and Hebrew, and occasionally a system of notation that only the person who wrote it could fully read. This is not an astronomical table, not an alchemical record, not a mathematical proof. This is a blueprint for a temple destroyed in the year 70 of the Common Era, when the armies of Emperor Titus swept into Jerusalem and leveled everything standing on the hill of Moriah so completely that, according to the historian Josephus, who witnessed it, no one looking afterward could tell that anything had ever stood there at all. The man sitting with that piece of vellum is Isaac Newton, and he is measuring, calculating, and reconstructing every centimeter of a structure that vanished 16 centuries before he was born, because he believed that within those numbers, God had hidden something that none of his equations could reach by any other path. To understand why Newton spent years on the Temple of Solomon, you first need to understand how he saw the universe, not the way he described it in the Principia, but the way he actually believed it operated at the deepest level. Newton believed that God had built the universe according to principles that could be discovered. This was not unusual. Most 17th century scientists believed something similar. But Newton believed it in a specific and deeper sense. He believed God had not only built the physical universe according to those principles, but had also hidden those same principles within human history, within sacred texts, within the architecture of structures built according to divine instruction, and most especially within the Temple of Solomon, the temple that Scripture says God himself designed and gave to King David and his son, Solomon, to construct. If God designed that temple, then its dimensions were not arbitrary. They contained information, and that information, if you possess the right mathematical tools to read it, might reveal things about the structure of reality that no other approach could access. This was Newton's logic, and once you understand that logic, the entire project of analyzing the Temple of Solomon suddenly seems far less like madness and far more like a man following a single thread of reasoning to wherever it leads. The primary source Newton worked with was the description of the temple in the book of Ezekiel, chapters 40 through 48, in which the prophet describes a vision of an ideal temple, with extraordinarily detailed measurements of every wall, every gate, every inner courtyard. In addition to this were the descriptions in the books of Kings and Chronicles of the actual temple Solomon built. The problem was that these descriptions were written in ancient Hebrew, using ancient units of measurement that by the 17th century, no one knew how to convert with any confidence into contemporary units. The main unit of measure used throughout the text was the cubit, the distance from the elbow to the tip of the middle finger. But how long was the ancient Hebrew cubit? Evidence suggested that at least 2 different cubits were used across the biblical text, a common cubit and a royal cubit, longer by roughly the width of a hand. Newton turned this problem into an independent research project. He gathered every historical document he could find on ancient units of measurement, from Hebrew sources, from Greek sources, from Josephus, from ancient geographers and historians, and tried to establish the absolute value of the ancient Hebrew cubit in contemporary terms. He wrote a separate treatise on the subject, a dissertation upon the sacred cubit of the Jews, not an archaeological exercise, but an essential preparatory step without which he could not begin his real measurements with any confidence. What Newton was searching for in the dimensions of the temple was not architecture in the ordinary sense. He was searching for ratios. More specifically, he wanted to know whether the proportional relationships between different parts of the temple reflected the proportional relationships he had already found in the physical universe. the ratios between the orbital distances of the planets, the ratios between orbital periods, the constants appearing in his equations about gravitational force. This was the idea that, expressed in modern language, we might call, do sacred architecture and sacred physics share the same grammar? Newton never found definitive proof, but he never abandoned the question either. In his manuscripts, calculations about the Temple of Solomon appear interspersed with calculations about planetary orbits, sometimes on the same page, as though for him, the two were not separate fields, but two different languages for speaking about the same reality. But Newton's research into the temple did not stop at measurements and ratios. It connected to another dimension, perhaps the most interesting and least known element of his entire intellectual legacy. Newton was interested in the Temple of Solomon not only as an architectural structure, he was interested in it as a cosmological model. In his theological writings, he argued that the design of the temple, with its concentric rings of spaces moving from the outer courtyard inward to the holy place and finally to the Holy of Holies at the center, reflected the structure of the universe as he understood it, a structure with a center, with layers, with the most sacred point at the core around which everything else revolved. Inside the Holy of Holies, according to the biblical description, there was nothing except the Ark of the Covenant and the presence of God. No lamp, no decoration, nothing made by human hands except the surrounding walls. And at the center of the solar system in Newton's model, at the point around which everything orbited, was the sun, the source of light from which all planets received their illumination, the force toward which all planets were pulled. Newton saw in those two images, the Holy of Holies and the sun, the same architectural principle, a sacred center that cannot be approached directly, only observed through what orbits around it. Was this theology or physics, poetry or science? For Newton, the question had no meaning. For him, it was all the same thing. There is a technical detail in Newton's temple research that historians of science have noted with particular interest. In the process of trying to establish the precise dimensions of the temple, Newton realized he needed a more accurate figure for the radius of the Earth than contemporary data could provide, because to convert reliably between ancient and contemporary units of measurement, he needed an absolute physical constant as a reference point, and the Earth's radius was the most natural constant available. The work of calculating the Earth's radius more precisely, work driven in part by the needs of the temple research, directly helped Newton refine the gravitational calculations that appear in the Principia. Which means, research into an ancient temple helped complete one of the greatest scientific achievements in human history. You cannot plan for that. You can only work with enough devotion across enough fields that unexpected connections have the chance to emerge. Beyond the Temple of Solomon, Newton also devoted considerable time to a closely related intellectual project. He attempted to reconstruct the idea of Prisca Sapientia, the ancient wisdom. This was a concept that had circulated through Renaissance thought and into the early modern period. The idea that a complete and comprehensive knowledge once existed at the very beginning of human civilization and had been gradually lost over the centuries, corrupted, fragmented, misread. The work of the philosopher and theologian was not to discover something new, but to recover something old. Newton believed in Prisca Sapientia, and he believed he was performing that work of recovery. Specifically, he believed that the ancient Greek philosophers, Pythagoras above all, had already known about gravity and the inverse square law. Not in the mathematical form he had written it in the Principia, but in the form of metaphor and symbol, encoded in stories about the music of the celestial spheres, about the harmonic ratios of the universe. He even wrote a passage he later decided not to include in the final printed version of the Principia, in which he argued that when Pythagoras spoke of the music of the spheres, he was actually describing gravity in the language of poetry. Newton did not believe he was discovering something new. He believed he was remembering something that had been forgotten. That shifts the meaning of his entire career in a strange way. We tend to think of Newton as the man who opened a door to the future, who laid the foundation for modern science, who came before Einstein, before quantum mechanics, before astrophysics. The view that faces forward, but Newton faced backward. He did not think of himself as opening a door to the future. He thought of himself as trying to open a long locked door back to a past when human beings knew more than they could still remember. Prisca Sapientia, the ancient wisdom, was his destination, not the future, a lost past. And the Temple of Solomon was the map. During the decades he worked on the temple, Newton accumulated a substantial collection of maps, drawings, and descriptions made by travelers and scholars who had visited Jerusalem. He compared them with one another, noted where they contradicted each other, and tried to reconstruct a coherent picture of what had once stood on the hill of Moriah. This work, reconstructing a structure from the fragments of incomplete descriptions, was perhaps the closest Newton ever came to allowing himself something like emotion in his work, because this was not the work of cold reason alone. This was the work of someone trying to see something that no longer exists from the scattered pieces of other people's memories. There is something in that image. The greatest scientist of the century, sitting with old vellum and faded maps, trying to sketch the walls of a vanished temple, that I find familiar in a way that is not entirely intellectual. All of us have our own Temple of Solomon, something lost that we cannot stop trying to reconstruct, some shape that we believe, if we could see it whole, would explain everything else. Newton called his the architecture of God. You might call yours by a different name. Around 1680, Newton came close to completing a reconstructed floor plan of the Temple of Solomon, the most detailed that any scholar had attempted at that time. He intended to include it in a larger work on historical theology he was writing. That work was never finished, never published. The drawing survives in his manuscripts, discovered after his death, and is now held at the National Library of Israel in Jerusalem, along with hundreds of pages of other theological manuscripts that the collector Abraham Shalom Yehuda purchased in the 20th century and donated to the library. There is something quietly poetic in the fact that the papers Newton wrote about the Temple of Solomon eventually came to rest in Jerusalem, the city where that temple once stood, where its foundations still lie beneath the ground today, as though those papers found their way home, even though the man who wrote them never left England. There is one more thing about Newton's temple research that I want to mention before we continue. Newton believed the Temple of Solomon was not only a cosmological model, it was also a prophetic code, a structure that, when correctly decoded, would reveal the schedule of history, including what was yet to come. This is the connecting point between his temple research and something else he devoted decades to: his analysis of the prophecies in the book of Daniel and the book of Revelation. Newton was not interested in prophecy in the magical or mystical sense. He was interested in it in the historical sense. He believed God had written history before it happened and encoded that pre-written account in the symbolic language of the prophets. And if you understood enough about actual history, you could read backward from events to prophecy, and then read forward to understand what still remained. This was the logic that led him to one of the most famous and least understood numbers in his entire legacy, the year 2060. And that is the story of the next chapter. If there is one thing you carry from this chapter, let it be this question. Newton lived in a world where everything, architecture, arithmetic, physics, theology, history, could be a language for speaking about the same reality. He did not divide the world into science and faith, into reason and feeling. For him, all of it was a different way of asking the same question. We lost that, the unity of the great question, when we learned to specialize. We were taught that scientists ask questions that can be measured, and theologians ask questions that cannot. And those two people should remain in separate rooms. Newton sat alone in his room and refused to accept that there were two rooms. Chapter 7 takes us to the number he calculated from all those years of study. The number that, when it was first made public, produced a small tremor in academic circles, not because it was wrong, but because it was right in ways no one expected from the man who wrote the Principia. The year 2060. Newton placed his bet on a number. And the reason he placed that bet is more complex, more interesting, and more human than any headline has ever managed to describe. Chapter 7, 2060. The final hour, Isaac Newton. The year 1704, 61 years old. He is sitting in London, in the house on Jermyn Street he had moved to after leaving Cambridge, with a candle held closer to his eyes than it used to be, because his sight had begun to weaken. On the table before him is the Book of Daniel. Not a standard printed edition, but a handwritten manuscript he had been working alongside for decades. Its margins so dense, with annotations in his own hand, that the margins had run out, and the notes had continued onto loose sheets of paper tucked between the pages. He is calculating, not planetary orbits this time, not chemical reactions in a laboratory closed 8 years ago. He is calculating something that most people, if they knew, would take as final confirmation that genius and madness share a wall with no insulation between them. He is calculating the date of the end of the world, or more precisely, because Newton was never imprecise, he is calculating the moment of the end of one age and the beginning of another. What the Book of Daniel calls the cleansing of the sanctuary. What Newton believed to be the most important historical prophetic event yet to occur. And the number he arrives at, recorded in a letter from 1704 and in several related manuscripts, is the year 2060. Before we talk about that number, we need to talk about how Newton approached prophecy, because his approach was entirely unlike what we usually imagine when we hear that word. Newton was not interested in prophecy in the sense of a person sitting down and receiving a message from heaven about what was going to happen. He was interested in prophecy as a system of historical encoding, a symbolic language that God had used to write history before it occurred, in a way that only those who understood enough actual history could decode. His logic was this: if the prophecies in the Book of Daniel about the ancient empires, about Babylon, Persia, Greece, Rome, had been fulfilled with precision in actual history, then the remaining portions of those same prophecies, the parts not yet fulfilled, were equally trustworthy. They were not imagination. They were history written in advance. This was the approach of a scientist. Identify the pattern in past data, then apply that pattern to make predictions about the future. No different in method from the way he used the observed orbits of planets to calculate where they would be at a future date. The difference was the input data, but the method, find the pattern, build the model, predict, was exactly the same method. The central text Newton worked with was chapter 8 of the Book of Daniel. which contains a unit of time called 2,300 evenings and mornings, traditionally interpreted as 2,300 days, and chapter 12, in which the numbers 1,260 days, 1,290 days, and 1,335 days all appear. These numbers, in the tradition of prophetic interpretation, were typically read according to the day-year principle, meaning each day in the prophecy corresponds to 1 year in actual history. This was not Newton's own idea. It had circulated in Christian theology long before him. But Newton applied it with a degree of historical precision that no one before him had attempted. The number he focused on most was 1,260, appearing multiple times in Daniel and repeated in the book of Revelation in various forms. 1,260 days, 42 months, a time, 2 times and half a time, all resolving to the same figure when calculated on the ancient Hebrew calendar. Newton's question was, 1,260 years counting from when? To answer that, he needed to identify the historical event that the prophecy used as its starting point, the moment from which 1,260 years began to run. And here is where Newton's historical research, hundreds of thousands of words on church history, on the councils, on the rise and fall of empires, became indispensable. Because to identify the starting point, he had to understand what was being described in the symbolic language of Daniel. Newton identified the starting point as approximately the year 800 of the Common Era, when Charlemagne was crowned Emperor of the Holy Roman Empire by Pope Leo III on Christmas night of that year, marking the formal union of political and religious authority across Western Christendom. This moment, in Newton's reading, was when the power that Daniel described in symbolic terms was officially established. 800 plus 1,260 equals 2060, the year 2060. This is the point where people usually stop and ask, did Newton actually believe the world would end in 2060? The short answer is no, or at least not in the ordinary sense in which that question is usually asked. Newton was not a person who found apocalypse exciting in the sense of destruction. He was not sitting with his calculations hoping everything would be swept away. What he was calculating, and what he described in his manuscripts with considerable care, was a transition, the ending of a historical phase and the beginning of another. What his theology called the establishment of the kingdom of God on earth. Not annihilation, but restoration. In the letter from 1704, written to an unidentified recipient, found in his manuscripts after his death, Newton is explicit that he does not identify 2060 as the year the world ends. He writes, "I mention this not to assert that this is the time of the end, but to put a stop to the rash conjectures of those who are frequently predicting the time of the end, and by doing so, bring the sacred prophecies into discredit." Read that again. Newton did not calculate 2060 in order to say this is the apocalypse. He calculated it in order to say this is the earliest possible outer boundary, and therefore anyone predicting the end of the world before that date was simply wrong. He used mathematics to refute apocalyptic predictions, not to join them. But there is far more in those prophetic manuscripts than a single number. Newton spent nearly 40 years writing about prophecy, analyzing not only Daniel, but Revelation, Ezekiel, Isaiah, and numerous other prophetic texts. The total volume of his writing on prophecy is larger than the total volume of his writing on physics and mathematics combined. And what emerges from that entire body of work is not the portrait of a scientist wandering into mystical territory. It is the portrait of a person trying to solve a specific intellectual problem. What historical evidence can confirm or challenge the claims made in sacred texts? This was an approach that no one else in the 17th century had thought to take. Theologians did not do this. They began from faith and interpreted history through that lens. Historians did not do this. They began from documented events and tried to stay away from sacred claims. Newton stood between both and asked, if we treat prophetic texts as historical evidence, neither blindly accepting nor dismissively rejecting them, what picture emerges? There is a section in Newton's prophetic work that few people know about, but that I find most worth noting, not because it concerns the apocalypse, but because it reveals how Newton understood his own place in history. In his manuscripts, there is a passage analyzing the 7 seals of the book of Revelation, and Newton argues that these seals do not describe the future. They describe history that has already occurred, written in symbolic form, and he attempts to match each seal to a specific period in the history of the Roman Empire and the early church. But what follows is what matters. After analyzing the seals that have already been opened, he writes about what he believes comes next. And in that description, he uses the language of the restoration of knowledge, that in the final age, there would be those who were given understanding of secrets long hidden, not through mystical revelation, but through serious study of texts and history. He never writes directly that he is one of those people. Newton did not have the habit of direct self-aggrandizement, but he was writing about the role of those who study seriously, and he was the one doing the studying, and he was finding things no one before him had found. You reach your own conclusion. In 1727, 1 year before Newton died, copies of some of his prophetic manuscripts were circulating in a small circle, not through formal publication, but through handwritten copies passed among his acquaintances. The response of those who read them, according to surviving records, was a quiet astonishment, not horror, not judgment, but the kind of astonishment you feel when someone tells you something you would never have expected from them, and you don't know quite how to process the information. Those people knew Newton as the father of classical mechanics. They did not know him as the man who had spent 40 years with the book of Daniel. They knew him the way the world wanted to know him, and they did not know him the way he actually was. But I want to sit with a genuine question here. A question not about theology or history, but about the nature of being human. Why did Newton spend so much time on this work? Not why in the intellectual sense. He explained his intellectual reasons clearly enough, but why in the psychological sense? What was it in the makeup of this particular man that made the question of the end of history, or of a great historical transition, a central question of a significant portion of his intellectual life? There is a theory that I find more persuasive than the simpler explanations. Newton was a person who experienced historical disruption very early and at a deeply personal level. His father died before he was born. His mother left when he was 3. The world he lived in was rearranged without his consent, multiple times before he was old enough to understand what was happening. And for the rest of his life, he searched for something that could hold steady, a constant, a principle, a pattern that did not change however much everything around it changed. In physics, he found laws of motion that do not change. In mathematics, he found structures that do not change. In theology, he searched for history that does not change, a stable plan hidden beneath the turbulent surface of time. The question of the end of history, of the final point of the story, is ultimately a question about whether there is a meaning. And a person who learned very early that the world could take away what you loved most without explanation, that person has particular reason to want to believe there is a plan, that there is a structure, that what was taken was not meaningless. Newton searched for meaning in the principles of the universe and in the prophecies of Scripture for the same deep reason. He needed to know the world was not random. The year 2060 is now 34 years away from where we stand tonight. That information means nothing and means a great deal, depending on how you approach it. If you approach it as a skeptic, as many people, including myself, tend to, then 2060 is simply a number arrived at by a great mind doing something outside his field of expertise. There is no reason to believe anything particularly significant will happen that year, rather than in 2059 or 2061. If you approach it the way Newton did, as someone who believed history has structure, that prophecy is historical code that can be read, then 2060 is a serious data point worth watching. And if you approach it simply as a human being living in the 21st century, then perhaps the most striking thing is not whether the number is correct, but the fact that the most intelligent man of the 17th century, the man who changed how the human race understands the universe, still needed to believe that history was going somewhere meaningful. That does not make him smaller. That makes him more human. I want to say one more thing about Newton's prophetic manuscripts before we close this chapter. For many centuries after Newton died, those manuscripts were nearly invisible. His executor, his nephew John Conduit, kept them private, understanding that if they were published, they would damage the reputation of his famous uncle. The family held them. Then they were sold, then dispersed, then bought back from various auction houses by various collectors. John Maynard Keynes, the economist, purchased the bulk of the alchemical and theological manuscripts at auction in 1936, and after reading them, offered the description "the last magician" that I mentioned in chapter 3. Abraham Shalom Yehuda purchased the remaining theological manuscripts, including most of the analysis of the Temple of Solomon and the prophetic writings, and eventually donated them to the National Library of Israel, where they are now digitized and available to read online. For the first time in history, anyone with an internet connection can read Newton's original handwritten manuscripts about the year 2060. The brown-yellow pages in his careful hand, the calculations in the margins, the crossed-out lines and revisions. There is something extraordinary in that. The man who kept secrets his entire life is slowly becoming completely transparent. Not because he chose it, but because time, given enough of it, dissolves every secret in the end. Newton died in 1727. He had 33 years fewer than the year 2060. He knew he would not live to see it. And perhaps that was part of the composure he carried into those calculations. He was not calculating in order to prepare himself. He was calculating in order to understand, to place something in its correct position within the larger structure. Whether that structure was the orbits of planets or the ages of empire. A man who spent his entire life measuring things larger than himself never expected to be present at the end of the measurement. He only needed to know there was an end, and that he had placed it correctly in the mathematical space of time. That had always been enough. Chapter 8 will take us out of the parchment pages and the manuscripts, out of the prophecy and the church history, and place us somewhere completely different. The dark alleyways of late 17th century London, where the man who calculated the apocalypse is sitting in a tavern in disguise, listening to criminals talk. Newton, warden of the Mint, is hunting someone. His target is William Challoner, a counterfeiter of such extraordinary skill that he had outmaneuvered the Mint for years and had the audacity to petition Parliament that Newton himself, the warden, was incompetent and unfit to protect the English currency. Newton read that petition, and then he arranged to meet Challoner in a way Challoner never anticipated. If you think you have understood Isaac Newton after 7 chapters, wait for chapter 8. Because there is a dimension of this man we have not yet seen, and it will surprise you. Not because it contradicts everything before it, but because it is entirely consistent with it, in a way that can only be seen once you know enough. Chapter 8. The Hunter at the Mint. London in 1696 was not a city you wanted to walk alone in after dark, not because of the lack of light, though the street lamps of that era were oil lanterns swaying in the wind, producing more shadow than illumination. Not because of the lack of people, though the people you encountered in the back alleys past midnight were not people you wanted to encounter, but because London at that moment was living through a financial crisis that, if left unresolved, had the potential to bring down the entire English economy. The coins were being faked, not on a small scale, on an industrial scale. The counterfeiters, coiners, as they were called in the English of that time, had developed techniques for shaving small amounts of precious metal from the edges of genuine coins, melting that metal down to strike fakes and releasing both types into circulation together. Real coins grew lighter, fake coins grew more sophisticated, and the financial system of an expanding empire was slowly losing its physical foundation. Parliament decided on a solution. All old coins would be recalled and melted down, and a new series, with more intricate designs, harder to forge, would be struck to replace them. This was called the Great Recoinage, and to carry it out, they needed someone to run the Royal Mint, who was not merely an administrative official, but a person who genuinely understood materials, processes, and people. They chose Isaac Newton. Newton accepted the position of Warden of the Mint in April of 1696. He was 53 years old. And here is what most people do not know. This position was nominally a comfortable sinecure. Previous wardens had come in for a few hours each week, collected their salary, and accomplished nothing significant. It was the kind of appointment given as a reward, not the kind that demanded real capability. Newton did not read the job description that way. Within weeks of taking office, he had moved his lodgings inside the grounds of the Tower of London, where the Mint was housed, and begun working 12 to 14 hours a day. He restructured the production process. He tracked output shift by shift. He inspected the quality of each batch of coins, and he began building a network of informants across the poor and criminal districts of London to hunt down the counterfeiters. From scientist and theologian, Newton had become a detective. The English legal system at the end of the 17th century was not a system you wanted to depend on if you were serious about prosecuting hardened criminals. There was no police force in the modern sense, no criminal investigation agency. To prosecute someone, you had to gather the evidence yourself, find the witnesses yourself, and build a case solid enough to persuade a jury yourself. Newton learned to do all of those things, and he learned with a speed that was striking even by his own standards. He established a network of paid informants, people who reported on counterfeiting activity in their areas. He personally interviewed suspects and witnesses, recording their statements in his own hand in notebooks. He carried the same way he had carried experimental notebooks his entire life. He sometimes dressed in plain clothes to enter neighborhoods where a gentleman of his standing would never appear in his usual attire. The taverns of the East End, the markets in the shadows under Southwark, the alleyways beneath the Thames bridges. We know this not from Newton's own proud accounts. He did not write memoirs about this period in any narrative sense. We know it from legal records, from interrogation transcripts, and from letters exchanged with his informants. All written in Newton's hand, in the same small and careful script he used for equations. But of all the cases Newton investigated during his years at the Mint, and there were dozens, leading to more than 20 prosecutions and executions, none consumed more of his time, energy, and personal attention than the case of William Challoner. William Challoner was one of the most fascinating and frightening figures in the criminal history of 17th century England. Born in Warwickshire, the son of a weaver, he grew up in poverty. He came to London looking for opportunity and found it. Not the legitimate kind, but a natural gift for making people believe in things that were not real. Challoner began his career selling fake medical remedies, treatments that contained none of what was printed on the label. He then moved into fake jewelry, and from there, one short logical step led to counterfeiting, which he practiced with a level of technical skill so high that even the experts at the Mint could not initially distinguish his coins from genuine ones. What made Challoner more dangerous than any other counterfeiter was not his technique. It was his audacity combined with a sharp intelligence. Challoner understood that the best way to escape prosecution was to become the person who prosecuted others. He repeatedly reported rival counterfeiters to the authorities, collecting rewards, building a reputation as someone who cooperated with the law, and simultaneously eliminating his competition. He was caught twice in connection with counterfeiting. He escaped both times, once for lack of evidence, once by successfully negotiating to trade information about another criminal network in exchange for his own immunity. And then, this is the part that even people who know this story often have to reread to be certain they have understood it. Challoner did the most audacious thing imaginable. He petitioned the English Parliament to be allowed inside the Mint to inspect its production processes and help improve them. He argued that with his knowledge of the criminal world, he could help the Mint produce coins that were harder to fake. At the same time, in that same petition, he declared that Newton, warden of the Mint, was incompetent, unfit to protect the royal currency, and should be replaced. Newton read that petition and understood immediately what Challoner actually wanted, not to improve the Mint, but access to its manufacturing secrets so he could produce even more sophisticated counterfeits. And not to criticize Newton on professional grounds, but to remove the one person who was genuinely hunting him. Beginning in 1697, Newton devoted most of his time outside the administrative work of the Mint to building a case against Challoner. The work took nearly 2 years, and it demanded a kind of patience entirely different from the patience of the laboratory. In the laboratory, you are patient with matter, with slow reactions, with inconsistent results, with the silence of elements that have no motive. Matter does not lie. It can be complex, difficult to read, but it has no reason to deceive you. Challoner lied, continuously, creatively, and convincingly. Newton had to learn to operate in an environment where every piece of testimony might be true, might be false, or, most complex of all, might be a carefully calculated mixture of both, designed to lead him toward a wrong conclusion that would weaken his prosecution. He adapted. And the way he adapted reveals something about his intelligence that no equation can show. He could read the motivations of other people with the same accuracy he brought to experimental data. He knew who was lying, not because he had supernatural intuition, but because he built enough information from enough different sources that inconsistencies in testimony became as visible as inconsistencies in experimental results. Newton's informant network was not simply a group of people he paid to report. He built a more complex system, multiple informants who did not know of each other's existence, so that information from one source could be checked against information from another. If two people who had no knowledge of each other provided the same detail about the same activity, the reliability of that information increased substantially. If they contradicted each other, he knew at least one person was fabricating, and the question became who and why. This was the scientific method applied to criminal investigation. Repeated experimentation, control variables, consistent results from multiple independent sources. Challoner knew he was being watched. He fed false information through people he knew would report back to Newton, trying to poison the source, trying to steer Newton toward wrong conclusions that would weaken the prosecution file. Newton was not fooled. Not because he was smarter. Challoner was also extremely intelligent, but because Newton was more patient. He was willing to wait until the case was solid, regardless of how long that took. Challoner did not have that luxury. He needed to keep operating, needed money, needed to keep moving. Newton's silence made him anxious, and anxiety made him make mistakes. There is a period during the investigation when Newton personally interviewed more than 100 witnesses and suspects, not through intermediaries, but sitting directly across from them, recording every word in his own hand. Those interrogation transcripts survive in the National Archives of England. Reading them today, they are strange and impressive documents in their own particular way. Newton's questions were short, never lengthy, never explaining why he was asking what he was asking. He would pose a question and wait, then the next question, with no obvious connection to the one before it, then a third question, returning to the subject of the first but from a different angle. This is an interrogation technique that, if the person being questioned is telling the truth, seems disjointed and directionless, but if they are lying, the gap between the first question and the third provides enough room for the fabricated account to begin contradicting itself. Newton did not invent that technique, but he used it with the precision of a man who had spent his entire life detecting inconsistency in data. Challoner was arrested for the last time at the end of 1698, but even while imprisoned in Newgate, London's most notorious jail, where conditions were grim enough to kill a person before their sentence was carried out, he did not stop fighting. He wrote letters, dozens of letters, sent to anyone who might help him. Members of Parliament, noblemen he had encountered, any acquaintance with enough influence to intervene. In those letters, he continued attacking Newton, accusing him of coercing witnesses, fabricating evidence, using illegal methods to build a case against him. And finally, desperate, Challoner did something that even those who knew him well did not expect. He wrote directly to Newton. That letter still exists. In it, Challoner, the criminal who had outmaneuvered the entire English justice system for more than a decade, who had been audacious enough to petition Parliament to have Newton himself removed, wrote in the voice of a man begging. He declared his innocence. He promised full cooperation, information about other criminal networks, anything he could think of to offer. Newton did not reply. William Challoner was executed by hanging at Tyburn in March of 1699. He was one of more than 20 people convicted of counterfeiting during the period Newton ran the mint. The method of hanging at Tyburn in the 17th century was not a quick death. There was no trapdoor designed to break the neck instantly, as in later techniques. The condemned was hoisted slowly and died of strangulation. a process that could take several minutes. Family members and friends were sometimes permitted to pull on the legs to shorten the ordeal. There is no record of Newton being present at Tyburn that day. But there is a record, in the notebooks he used to track the progress of his cases, of the verdict and the date of execution, recorded in Newton's hand, in the same small and careful script. No additional commentary, no reflection, only the fact and the date, like a laboratory entry being closed. After Challoner's death, Newton continued running the mint for another 27 years, until his death in 1727. In 1699, he was promoted to Master of the Mint, the highest position, replacing the Warden, a more lucrative role and less demanding in practical terms. But he did not return to Cambridge, did not return to the laboratory, did not return to the alchemical notebooks, though he had likely brought them with him to London. Something about the mint years changed Newton in a way that is not always obvious if you only look at the surface of his biography, not in the sense that he became better or worse, but in the sense that he became different. The man who had once avoided the world, who worked best in complete silence in the self-imposed darkness of the laboratory and the study, had spent 10 years going deep into the most immediate, most material, and most frequently dark aspects of human reality: money, crime, power, and death. And he had done that work well, not because it came naturally to him, but because he applied the same principle that had helped him do everything else. Begin with the question, gather the evidence, draw no conclusion before the evidence is sufficient, and be more patient than anyone else in the room. There is a small detail from Newton's mint years that I find says something more important than any story about catching criminals. Newton, during this period, began using a preparation called theriac, or Venice treacle, a compound medicine with roots in ancient Rome, used to treat everything from stomach pain to anxiety. What is notable is that theriac in the 17th century commonly contained opium as its primary active ingredient. Newton, who had suffered chronic mercury poisoning from 30 years of laboratory work, whose nervous system had been damaged to a degree we cannot precisely measure, who was running a large institution while simultaneously writing about theology and prophecy, may have been using opiates to manage pain and insomnia that he almost never mentioned in anything he left behind. This is informed speculation, not confirmed fact, but it is a reminder of something. The body of this man paid a price for everything his mind accomplished, and that price was paid in silence, like everything else that mattered to him. There is a strange parallel with Marcus Aurelius, the emperor and Stoic philosopher whose spirit this channel carries something of, who is also recorded as having used opiates in his later years to manage chronic pain. Both were men of extraordinary will. Both maintained careful distance from the world around them while fully performing their responsibilities within it. And both paid a physical cost for the sustained effort of being themselves across a long life. The mint years ended not with a dramatic event. They simply continued, year after year, Newton sitting at the mint, signing documents, supervising production, occasionally handling another counterfeiting case, but never with the same intensity as the Challoner affair. His reputation grew in directions Cambridge had never allowed. He was elected President of the Royal Society in 1703, a position he held until his death, 24 consecutive years. He was knighted in 1705. He became the official face of English science, the figure that every distinguished visitor to London wanted to meet. And in all those years of public reputation, none of the people who encountered him at receptions and formal dinners knew about the notebooks in the drawer, about the Temple of Solomon, about the year 2060, about the 47 sins recorded by a 20-year-old boy at Cambridge. They saw Sir Isaac Newton, President of the Royal Society, the man called the greatest genius of the age. He allowed them to see that, and continued being someone else in the privacy of his evenings. Chapter 9 takes us backward in time, back to 1693, before all the mint years and the public reputation, to the darkest moment in the life of Isaac Newton. In 1693, Newton came close to breaking completely. He wrote letters that, when read today, you do not recognize as coming from the same person who wrote the Principia. He described insomnia so severe he could count on his fingers the nights he had slept across entire weeks. He accused his closest friends of crimes he had no evidence for. And then he went silent. A silence longer and deeper than any that had come before. What happened in 1693 has no definitive answer, but there are clues. About a man named Fatio de Duillier, about Mercury, and about the possibility that what broke open that year was not the collapse of a genius, but the rupture of everything that had been held too tightly for too long. If you are still with this story, wherever you are, whatever hour it is, you have traveled alongside Newton through laboratories and theological manuscripts and the dark alleyways of London. Chapter 9 is the last room before we begin to see the door, and sometimes the last room is the hardest one to pass through. Chapter 9. The collapse of 1693. There are moments in a person's life when everything being held together, by will, by habit, by focus on work, by the careful distance maintained from the world, suddenly is not enough anymore. Not because something new has happened, but because everything old has accumulated long enough, heavy enough, to reach the point where even the most carefully constructed structure cannot bear any more weight. In the autumn of 1693, Isaac Newton, 50 years old, at the height of his scientific reputation, admired by all of learned Europe, collapsed, not in the metaphorical sense, in the real and specific and deeply alarming sense that left those around him with no idea what to do. The first and clearest evidence comes from the letters. In September of 1693, Newton wrote to Samuel Pepys, the diarist, government official, and long-standing acquaintance. The letter was short, almost incoherent, and contained a declaration that Pepys, who had known Newton for years, must have read and reread several times to be certain he had understood it correctly. Newton wrote that he was experiencing a great disturbance of mind, unlike anything he had ever experienced before, that he no longer trusted himself as he once had, that he wished to withdraw from all relationships, not temporarily, but permanently. He asked Pepys not to contact him again. A few days later, he wrote to John Locke, his most trusted friend, the only person who knew about the heretical manuscripts. This letter was worse. Newton accused Locke of having endeavored to embroil me with women and by other means. He wrote that he had cursed Locke in his heart and wished that Locke were dead. Locke, who had known Newton long enough not to respond with anger, replied with careful concern. He asked whether Newton was well, whether he needed any help. Newton wrote back. This time he apologized. He explained that he had not slept an hour's sleep in 5 nights together, and that his mental state during that period could not be trusted. 5 nights without sleep. He recorded that number himself. Those letters, preserved and later analyzed by historians, are the only documents we have about what Newton experienced from the inside during those months, and they raise more questions than they answer. Why did Newton accuse Locke of things without foundation? Why did he suddenly want to sever all connections? Why did those 5 sleepless nights, or close to it, arrive at precisely this moment in his life? There are 3 main theories that researchers have proposed, and the truth, if any definitive truth exists, is probably a combination of all 3. The first is the chemical theory. Chronic mercury poisoning had reached a level that was seriously affecting Newton's central nervous system. We spoke about this in Chapter 3, about the analysis of Newton's hair showing mercury levels approximately 7 times higher than normal. But it is important to understand that mercury poisoning does not operate in a straight line. It accumulates. And beyond a certain threshold, symptoms that had been quietly present in the background, chronic insomnia, anxiety, agitation, difficulty concentrating, changes in personality, can suddenly escalate into acute crisis. The modern medical term for this condition is erythism mercurialis, the neurological syndrome resulting from chronic mercury poisoning. Its symptoms include severe insomnia, pathological anxiety, extreme shyness alternating with uncontrollable outbursts of anger, pathological suspicion of those nearby, and in severe cases, hallucinations and loss of the ability to judge reality. Place that list of symptoms alongside what Newton described in his letters of 1693. The correspondence is not perfect. It never is in historical medicine, but it is sufficient to raise serious questions. The second theory is spoken about less often, not because it is less convincing, but because it requires us to discuss a subject that for many centuries people chose not to discuss. The person's name was Nicolas Fatio de Duillier. Fatio, Swiss, a mathematician, 24 years old when he and Newton first met in 1689, became the person closest to Newton in any real sense of that word during his adult life. This needs to be stated clearly. Newton did not have friends in the ordinary sense. He had colleagues, students, people who respected each other's work across the safe distance of correspondence and occasional meetings at the Royal Society. He did not invite anyone into his private life. He did not share meals with anyone habitually. He had no habit of simply sitting with another person for the sake of sitting together. Fatio was the exception. In the period roughly from 1689 to 1693, the letters between Newton and Fatio had a frequency and a tone unlike anything else in all the documents Newton left behind. Newton wrote to Fatio about personal things, not theology, not mathematics, but about Fatio's health, about his travel plans, about Newton's concern when Fatio fell ill. There is a letter Newton wrote upon hearing that Fatio was seriously unwell, in which he proposed, with a specificity and urgency uncharacteristic of him, that Fatio should come to Cambridge and stay, that Newton would arrange everything, that he wanted Fatio nearby. Fatio, for his part, wrote to others about Newton with an admiration bordering on reverence, describing him as the most extraordinary person he had ever encountered, someone for whom he felt a particular esteem and affection. The precise nature of that relationship, whether it had a romantic dimension, is something historians have debated for decades and will continue to debate, because the evidence is not sufficient to reach a definitive conclusion in either direction. The 17th century had a language of intimate friendship that today we read differently, and historical caution requires not mapping modern categories onto the past arbitrarily. But there is this. For a man who had lived his entire life in careful isolation, who had never permitted anyone to come close, the relationship with Fatio was the nearest Newton came to what an ordinary person might call intimacy. In 1693, Fatio left England. not permanently. He returned to London afterward. But in the spring of 1693, he wrote to Newton that his health required him to go, that his future was uncertain, that he did not know when he would return. And a few months after that, in the autumn of 1693, Newton collapsed. There is no direct evidence connecting those two events. Newton did not write, "Fatio has gone, and therefore I am broken." He never mentioned Fatio in the letters about his mental state. But the timing is there. And those who understood Newton, the man who never expressed personal pain directly, who always attacked at an angle rather than head-on, who processed everything personal by turning it into something else, would perhaps not be surprised if the loss of the only real connection in his adult life contributed to what happened next. The third theory is less dramatic, but may be the most important. This was simply exhaustion. Consider what Newton had done in the 20 years before 1693. He had written and published the Principia Mathematica. The process of composing that book, according to testimony from people who knew him during that period, was an act of intellectual concentration so total that he regularly forgot to eat, forgot to sleep, forgot that there was a world outside the page he was writing. He did this while simultaneously continuing to study alchemy, writing about theology, and managing administrative responsibilities at Trinity College. He did all of those things in a body being slowly damaged by mercury, in a mind that had never truly rested, not for lack of opportunity, but because he did not know how to turn the questions off. And he did all of it alone, with no one to share the burden, no one to whom he could say, "I am tired today," and know that the other person understood in any real sense. 50 years of that. And in the autumn of 1693, the structure gave way. What is remarkable about the collapse of 1693 is not the collapse itself. It is what happened afterward. Newton did not lose his mind. He was not institutionalized. He was not removed from the academic community. He went silent for a few months, and then, slowly, without any formal announcement, without any declaration of recovery, he began to reappear, answering letters, attending meetings, performing his work. But those who knew him noticed the difference. Humphrey Newton, the secretary who had been close to him in the years before the collapse, described Newton before 1693 as someone who seemed to be continuously in a state of intense concentration, a man you could see thinking even when he was sitting, eating, or walking. After 1693, according to Humphrey, something in that intensity had diminished, not disappeared. Newton still worked, still wrote, still presided over the Royal Society with precision and authority. But the fire of the laboratory, the fire of a man searching for something he had not yet found, burned lower. After 1693, Newton did not produce any significant new fundamental scientific work. He arranged and published things he already had. He expanded and refined. But the great discoveries, the kind that happened at Woolsthorpe, the kind that built the Principia, belonged to the life before 1693. There is a way to read that as tragedy. A genius extinguished too early, 30 years of productivity lost. But there is another way to read it. Newton had given the world what he was capable of giving in the time he was capable of giving it. Optics, calculus, gravity, the Principia. All of it existed before 1693. The scientific world was digesting it across decades and would continue digesting it across centuries. What he did after 1693, running the Mint, presiding over the Royal Society, continuing to write about theology and prophecy, was not the remainder of a life that had run dry. It was a different portion of the same life, lived under different conditions. A person is not only what they produce in their peak years, they are also what they choose to do after the peak has passed. But I want to return to Fatio one more time, because his story did not end with his departure from England in 1693. Nicolas Fatio de Duillier, the young Swiss mathematician, the person Newton trusted more than anyone else in his adult life, after 1693 went through a journey of his own in a very different direction. He became a fervent follower of a small religious movement, the French Camisards, also known as the French Prophets, a group of Protestant believers who held to direct revelation and sometimes expressed this through public trances and prophetic utterances. Fatio did not merely follow this group. He became one of its most vocal leaders and spokesmen in England. He was arrested and sentenced to stand in the pillory, a public punishment of humiliation, for distributing materials considered seditious on religious grounds. Newton never publicly associated himself with Fatio after he joined that movement. No correspondence survives from after 1693 between them. Or if it does exist, it was destroyed or lost. We do not know what Newton thought when he heard about Fatio's journey, whether he read about the trial and the punishment, whether he felt anything, grief, contempt, or something without a clear name, when the one person he had ever allowed near became what Newton, with all his caution about faith and reason, could never have been. A prophet who needed no evidence, a person who stood before an audience and spoke of messages from God without requiring texts, without requiring history, without requiring mathematics. Newton had spent 40 years decoding prophecy through historical and mathematical method, and the person who had been closest to him chose the path of direct revelation. The exact opposite. There is something quietly painful in that, but also something true about the distance between people, even people who were once genuinely close. We cannot always follow each other into the rooms we each eventually find ourselves in. 1693 ended. 1694 began. Newton returned to work. No announcement, no explanation. Nothing in his correspondence afterward referred to those months as a particular period. He simply continued, as though if continuing were persuasive enough, those months would become a parenthesis in a long life rather than a breaking point. And in one sense, he succeeded in creating that impression. People who knew him after 1693, who encountered him at the Royal Society, who received his letters on scientific matters, who dined with him at formal receptions, did not necessarily know about the letters to Pepys and Locke, did not necessarily know about the 5 sleepless nights. They saw Sir Isaac Newton, calm and authoritative as always. But those who truly paid attention, and there were a few, noticed what Humphrey Newton had described. That something behind those eyes had changed, that the person sitting before them was still a genius, still sharp, still precise, still formidable in his understanding, but was no longer searching in the old sense. The person who is searching has a particular quality in their eyes, not joy. Newton had never been joyful in any conventional sense, but the tension of someone drawing closer to something they have not yet been able to touch. After 1693, that quality faded. Not completely, but it faded. There is a question I have been carrying across all 9 chapters of this story, and I want to ask it plainly here before the final chapter. We have seen Newton in the laboratory, in the study, in the dark alleyways of London. We have seen him with the prism and the needle in his eye, with the book of Daniel and the blueprints of the temple, with interrogation transcripts and networks of informants. We have seen him furious with Hooke, careful with Locke, Close to Fatio in a way he was close to no one else. Through all of it, was he happy? That question sounds naive when asked about someone like Newton. Happiness was not a category he thought in. He left no language for it in anything he left behind. But there is another way to ask it. Did he get to live the life he wanted to live? And the answer to that question is more complex and sadder. He lived the life he had to live. The life shaped by what happened at Woolsthorpe when he was 3 years old, by those months at his grandmother's house, by the infant who could not sleep in a body born too early into a stone house in the middle of a Lincolnshire winter. He lived it with complete dedication and extraordinary intensity. But wanted, in the sense of a person standing before genuine choices and choosing freely, is not quite the right word. He did not choose solitude because he preferred solitude. He chose it because it was the only thing he knew how to do safely. And safety, not happiness, not satisfaction, but the pure safety of a person who knows they will not be hurt again, is sometimes the best that a life shaped by early loss can manage. Autumn of 1693 passed. Newton did not speak of it again. Fatio de Duillier faded from the pages of his biography, the way a figure fades in a dream that the dreamer cannot clearly recall by morning. And Newton, the man who had threatened to burn his stepfather alive at age 5, who had driven a needle into his own eye to understand light, who had inhaled mercury for 30 years in dark laboratories, who had decoded the apocalypse in secret, who had hunted criminals through the alleys of London, continued, as he had always continued, because it was the only thing he knew with certainty was right. When there is nothing else to hold on to, keep working, keep asking, keep sitting down with the blank page and the ink and asking, what comes next? Chapter 10, the final chapter, brings us to the last years of Newton's life, to the South Sea bubble and the money he lost, to the dog Diamond and the story behind that story, to the bedroom at Kensington where he died alone, refusing communion, with all those notebooks still locked in their drawers, and to the final question about his real legacy, not the legacy the world decided on, but the legacy that Newton himself, if asked on that last night, might have chosen. If you are listening to this, and tonight is one of those long nights, if you are somewhere in the dark of a period you haven't yet found a name for, know that the man who changed how the human race understands the universe had nights like that too. 5 nights without sleep, letters of apology with no clear reason, the silence that followed. And then he continued, not because he was better, not because everything had been resolved, but because continuing was the one thing he knew how to do well. Sometimes that is enough. Chapter 10, the South Sea bubble and the shore of truth. There is one thing Isaac Newton never understood. Not light, not gravity, not the symbolic language of the prophets or the architecture of the Temple of Solomon, not mercury or gold or the secrets of living metal. The thing Newton never understood was human beings. When they gathered into crowds and began believing what they wanted to believe, rather than what the evidence supported. And in 1720, that cost him a sum of money equivalent to several £1 million in today's value, lost within a matter of months, leaving behind almost nothing except a short remark he was said to have made afterward, a remark that became one of the saddest sentences a genius has ever spoken aloud. The South Sea Company was established in 1711 as a financial instrument to manage England's national debt. Its business model was complex in the way that most people who invested in it did not truly understand, and that, as so often happens in the history of finance, was part of the problem. The company promised enormous profits from trade with the Spanish colonies in South America. Those trades were largely illusory. The actual commercial rights England held in that region were severely limited, and the company's leadership knew it. But they also knew something else, that if you generated enough expectation, enough stories about coming profits, enough excitement in the coffee houses and drawing rooms of London, people would buy out of fear of missing out, not because they understood what they were purchasing. The stock of the South Sea Company began 1720 at around £100 per share. By June of that year, it had risen above £1,000, a tenfold increase in 6 months. London went mad. Everyone, from the nobility to merchants to household servants, sold assets, borrowed money, did whatever was necessary to buy shares. Isaac Newton bought too. Here is what most people do not know. Newton was not naive about the South Sea Company. He bought early, in the beginning of 1720, when the price was still low, and sold in the spring with a profit of around £7,000, a very substantial sum. He had gotten out, at the right moment, in the right way. But then he watched the people around him, friends, colleagues, acquaintances at the Royal Society, continuing to make money as the stock kept rising after he had sold. And he did what the most intelligent person in the room sometimes does. He changed his mind. He bought back in, this time in far larger quantities, at far higher prices, at precisely the moment the bubble was preparing to burst. In September of 1720, the South Sea Company collapsed. From its peak above £1,000 down below 100 in a matter of weeks. Thousands of families lost everything. Parliament was forced to open an inquiry. Several of the company's leaders were arrested. Newton lost approximately £20,000. By various estimates, possibly more. In today's value, that figure runs into the millions. Afterward, he was said to have remarked, or written, depending on the source, the following: "I can calculate the motion of heavenly bodies, but not the madness of people." That exact phrasing may not be perfectly accurate. No original handwritten copy of it in Newton's hand survives, but it was recorded by those who knew him as reflecting what he actually said or felt. And whatever its precise origin, it is true in a way that runs deeper than it first appears. Newton had spent his entire life understanding systems. Systems with rules, with principles, with structures that could be discovered and described in mathematics. Planets move in ellipses for a reason. Light separates into color because of structure. Even history, in his view, had a structure encoded in prophecy. But crowds do not operate that way. Crowds operate on the logic of emotion spreading, of the fear of being left behind, of greed socialized into collective excitement, of trusting the people who are making money right now, rather than trusting a cold analysis of what can continue and what cannot. And Newton, who had resisted social pressure in every other domain of his life, who had kept his heretical theology secret for 50 years without yielding, who had refused to publish until he was certain, could not resist this. Why? Perhaps because after 1693, after Fatio's departure, after the slow fading of the searching fire, Newton needed something to replace the drive he had lost. And in 1720, that something happened to take the shape of rising stock prices and people around him growing wealthy. Or perhaps, more simply and more sadly, the most intelligent man of the 17th century was still only human, and human beings make mistakes about money in ways that intelligence does not protect against. After the losses from the South Sea Company, Newton never mentioned them in any surviving letter or note. No analysis of what had gone wrong. No recorded regret. Nothing. That silence, in a certain sense, was entirely consistent with the man he had been his entire life. The most painful things were never spoken aloud. They were put away in a drawer, or converted into work, or simply left behind as he kept moving forward. He kept moving forward. 7 more years, until 1727. In his final years, Newton lived at Kensington, then still a village on the outskirts of London rather than the city centre it is today, in a comfortable house that his grandniece Catherine Conduit and her husband John Conduit had arranged for him so he could have cleaner air than the increasingly polluted centre of London offered. Catherine Conduit was the woman closest to Newton in his final years, not because he had chosen that closeness, but because she had chosen it for him, with the patience and the kindness of someone who understood that her great-uncle did not know how to ask for care, but still needed it. She recorded observations about him during those years, small fragments about his daily habits, about things he said and did not say, about how he aged. Those notes, compiled by John Conduit after Newton died, are the most valuable source we have about Newton as a person in his final years, not as a scientist or an official, but as an old man moving toward the end. And here is where the story of the dog Diamond belongs. This is one of the most frequently repeated stories about Newton, and also one of the stories with the most different versions, to the point where it is unclear which version is true or whether it happened quite as people tell it. The standard telling goes like this. Newton had a small dog named Diamond. One day, while Newton was in the adjoining room, Diamond knocked over a candle on his desk, and the flame destroyed many years of research and unfinished manuscripts. When Newton returned and saw what had happened, he said to the dog, "O Diamond, Diamond, thou little knowest the mischief thou hast done." No tears, no anger, only that sentence. There are several problems with this story. First, no contemporary evidence confirms it. It appears in later accounts, retold by people who were not present. Second, it is unclear whether Newton actually kept a dog. He was not known for any particular affection toward animals. Third, if the event occurred and caused significant damage to manuscripts, we would expect some trace in his correspondence, and there is none. But the story survives, and perhaps it survives not because it is factually complete, but because it is true about something else. It captures something real about Newton, about a man controlled enough to face loss with composure, and lonely enough to say the most important thing he was thinking to a dog rather than to a person. Whether the story is literally true or not, it has become part of the Newton that history remembers. And sometimes a story contains a different kind of truth, not the truth of what happened, but the truth of who someone was. In early 1727, Newton's health failed visibly. He was 84 years old, a remarkable lifespan for any century, and particularly extraordinary given all the mercury, all the sleepless nights, all those years of working under conditions that modern medicine would consider entirely unacceptable. In his final weeks, he rarely left his bed. Catherine Conduit sat beside him. John Conduit recorded what he said, disconnected sentences, sometimes about his work, sometimes about things that were unclear, whether he was speaking of the world inside or the world outside. There was one night, according to John Conduit's record, when Newton woke and spoke clearly with the calm voice of a man posing a question in a laboratory. "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore. and diverting myself in now and then, finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. That sentence, unlike the diamond story, has considerably stronger evidence behind it. John Conduit recorded it close to the time it was spoken, and is entirely consistent with how Newton thought, not humble in the sense of self-diminishment, but in the sense of a person who knows precisely the distance between what has been understood and what remains to be understood. The man who found the law of universal gravitation, who invented calculus, who decoded the structure of light, who wrote more than 1,200,000 words on theology and prophecy and alchemy and history and architecture. That man, at the end of his life, looked back across everything he had done and saw, not achievement, not legacy, but the shore of an ocean he had barely begun to enter. On the 21st of March 1727, at around 1 in the morning, Isaac Newton died. No one was beside him at that moment. Catherine and John Conduit were asleep. The medical attendant was not in the room. He died alone. As he had lived alone in the sense that mattered most, not physically, but in terms of the things inside that were never fully shared with anyone. He was buried at Westminster Abbey, the highest honour England could bestow on a citizen. Voltaire, the French philosopher then in London, attended the funeral and afterward wrote about it with undisguised admiration. Here, he said, was a nation that honoured its scientists the way other nations honoured kings. Monuments were raised. His name was given to schools, streets, units of measurement. The story of the apple was retold until it lost nearly all its original complexity and became the clean symbol of a moment of genius. And the notebooks in the drawer about the Temple of Solomon and the year 2060 and the Trinity and Alchemy and the 4 undeciphered words Nabed Ephig were put away by his executors, who understood that the world was not ready for the real Newton. Let us stop here and ask, what was Isaac Newton's real legacy? Not the legacy the world decided on, not the Principia, not the law of universal gravitation, not calculus. Those things are his legacy in the sense that the history of science records them. They are real and important and have changed everything. But if Newton, on that last night, alone in the bedroom at Kensington, had been asked, "What do you want to be remembered for?" the answer might not have been the Principia. It might have been the question. Any one of the thousands of questions he had posed that went unanswered, and the fact that he never stopped posing them, even knowing he would not live long enough to hear the answer. About the invisible force connecting atoms, about the organizing principle behind the silver tree growing from liquid, about what the number 2060 meant in the actual running of history, about whether the God he had believed in so completely was truly the God he had refused communion for on his final night in order to remain honest. Not one of those questions was answered, and Newton knew that at the end, but he had asked them, and in some sense, asking the right question matters more than finding a wrong answer. There is one final thing I want to say about Isaac Newton, not about science or theology or alchemy, but about this. He was a person who was abandoned at age 3 and never fully learned to trust that another person's presence would last. He carried that across 84 years, through every laboratory, every argument, every page of theological manuscript, every sleepless night. And with all of that, with all the wounds and the solitude and the distrust and the mercury and the secrets held too long, he still produced things of extraordinary beauty, things that 300 years later remain the foundation of how the human race understands the universe. That does not mean wounding is necessary for greatness. that does not mean solitude is the condition of genius. Be careful with that kind of conclusion. It romanticizes things that deserve no romanticizing. What it means is this: human beings can make beautiful things from imperfect materials, can build with broken tools, can ask the right questions even without the language to fully express why those questions matter. Newton was not the myth. He was a person. And that, strangely, makes what he accomplished more impressive, not less. We have traveled through 10 chapters, 3 hours, from a stone farmhouse in Woolsthorpe in the winter of 1642 to a bedroom in Kensington in the early morning of the 21st of March, 1727. We have seen the child who wrote 47 sins into a notebook, the young man who drove a needle into his own eye to understand light, the man who stood before his alchemy furnace in the Cambridge night, breathing mercury and searching for something without a name, the scholar who kept a heretical secret for 50 years, the investigator who sat in disguise in London taverns, building a case against the most audacious criminal of the age, the old man looking out at the shore of an ocean of truth he knew he would never swim across. And through all those images, through all the dark rooms and the written pages and the unanswered questions, there is one consistent thread: the refusal to stop. This, I think, is what Isaac Newton, not the myth, but the man, wanted to leave behind. Not a law or an equation or a published work, but the practice of sitting down with the hardest question you have and not standing up until you have gone a little further than when you began. Not finding the answer, just going a little further. Picking up one more smooth stone on the shore, and then one more, and knowing that the ocean ahead will still be vast when you are done, and doing it anyway. If you have been with this story from the beginning to the end, if you have traveled through all 10 chapters, whether in one night or across many, then you know something now that you did not know when you started, not just about Newton, but about the kind of question a life can be built around. And that, in my view, is the only thing any story can truly give you, not the answer, but a better question to carry forward. Thank you for being here, wherever here is for you tonight. Whether you are in a city that never quite goes dark, or a room so quiet you can hear your own breathing, or somewhere between two places on a long journey you did not entirely plan. Whether this is the end of your night or the beginning of your morning or the strange middle hour when time stops feeling like it belongs to either, if this episode gave you something worth keeping, a night of better rest, a question you did not have before, or simply the feeling of not being alone in the dark, leave a like and subscribe so you don't miss what comes next. That is how you tell me that slow and deep things still have a place in this world. And if there is one sentence, one image, one moment across these 10 chapters that stayed with you, leave it in the comments. You don't need to explain it. Just let it be known that you were here, that you listened, that you carried something of your own through this story. I read every single one. The Stoic Slumber will return.